Good morning everyone, this is Anagon Live and day 19 is starting. We're ready to go and our Advent of Code site is on the right, so let's open up day 19. I haven't finished day 18 even yet. Puzzles are getting very hard, but let's see if day 19 is a little bit easier. Day 19, Tractor Beam. Unsure of the state of Santa's ship, you borrow the tractor beam technology from Triton. Time to test it out. When you're safely away from anything else, you activate the tractor beam, but nothing happens. It's hard to tell whether it's working if there's nothing to use it on. Fortunately, your ship's drone system can be configured to deploy a drone to specific coordinates and then check whether it's being pulled. A tractor beam is some beam that pulls stuff towards you, like the gravity gun in Half-Life, for example. There is even an int code program that gives you access to the drone system. Okay. The program uses two input instructions to request the X and Y position to which the drone should be deployed. Negative numbers are invalid and will confuse the drone. All numbers should be 0 or positive. And it's not a very long instruction, so I think I can do without notes right now. Then the program will output whether the drone is stationary or being pulled by something. For example, 00 is directly in front of the tractor beam, so the drone control program will always report 1 at that location. To better understand the tractor beam, it's important to get a good picture of the beam itself. For example, suppose you scan 10 by 10 points closest to the emitter, then you'll see the number of points affected by the tractor beam in the 10 by 10 area closest to the emitter is 27. I didn't understand this phrase. The number of points affected by the tractor beam in the 10 by 10 area closest to the emitter. Okay, yeah. So the emitter only goes in the positive direction, right? And the number of points affected is 27. However, you'll need to scan a larger area to understand the shape of the beam. How many points are affected by the tractor beam in the 50 by 50 area closest to the emitter? Okay. For each X and Y, this will be from 0 till 49. So that seems like something we can easily solve. Well, it sounds easy unless our int code computer is going to take an hour for each point, of course. I guess that is the question. Maybe we have to optimize our int code computer. I hope not. Let's go to day 19 and actually I should save it. So let's see, day 18, 19. Save it. And make a new file. Day 19. Oh well, let's copy our code from day 18 to parse the input. So that's something we always do anyway. So day 19 input. And we're going to read a single line. And we're gonna strip it. So that is this first line, and we'll strip it. And that is going to be the raw input. And then we'll split it also. Maybe we'll just split it right away. And I do see some kind of negative. Oh, I'm doing the same stupid mistake as before. This is int code. This is int code. I don't need to parse it. I don't need to parse it. Okay. I see Alex has already solved part 1 and Crespel also, so that is very quick. Wow. You guys are so fast. So my int code computer from day 9. That's here. Computer.load from file input. No, day 19 / input.txt. And then I'm going to set debug mode is false. And I'm going to run the program. I'm going to pass it inputs actually. So we're going to try all inputs. So for x, y in, let's say in positions equals a double loop for x in range 0 to 50, for y in range 0 to 50 also. That means we have all xy. It should be like this. xy for x in range and for y in range. And I think to get the horizontal ones first, you should start with the y loop, but doesn't matter. Okay, so computer.input is all of the positions, but I have to... No, I can actually run the whole program and say that the input is the positions, and then we'll need to get the output and how many are affected. So that is just basically the computer output, and we're going to count. Oh, you can do count. Not sure how that works. Count 1. Return the number of occurrences of value. Wow, that is so easy. So we'll run it, and let me pop this back in to my screen. So we have it here on the bottom, and I got an unexpected keyword argument because it's supposed to be inputs, and we are not able to do something. I'm getting some strange error message. Less than is not supported. Oh, okay, I need to actually... What am I doing? I'm passing positions right straight away. That is not possible. So the computer's inputs are going to be an empty list. Oh man, now I shouldn't have used this thing actually. I should have just made a for loop. For y in range 0 to 50, for x in range 0 to 50. I can get this done quickly too, guys. Come on. Inputs dot append x and then y, right? What do we say? First, how is that? Two inputs, the x and the y, and they should be 0 or positive, and the inputs are the inputs, and we'll run it. I get 1. That sounds very incorrect. That sounds very incorrect. Should not be 1. No, come on. I'm not sure I trust count here. So I'm going to do computer.output, but everything, just everything. And it looks like this. So we have only 1. Oh, we can run it only once. Oh, I see. Okay. Oh, okay. So we actually have to run the program and get a single output, and that would look like. I'll just call it yes. If the output is a 1, then I'll add yes. Outputs 0 equals 1, then yes is plus 1. And we'll print it. Outputs doesn't work. Output 2500. That sounds like everything. That should also be incorrect. The program uses 2 input instructions to request the x and y position. Okay, and it will output whether the drone is stationary or being pulled. Okay. You'll need to scan a large area. Okay, but why do we get 1 every time? Basically, I should do it like x and y, right? And that's it. Maybe I need to reset something? Okay, I'm going to turn on debug mode and see what happens. So it is running for quite some time. At least let's try the first time only. Breakpoint. You think each drone is independent? Okay. And let me pop this down also. Like this, pinned. So this is the run for the first time, and it's quite a long program, and we have some input here, 0 and 0, and then after some time we do get an output, finally, 1. And then what happens? Does it actually ask for input or not? It's not saying waiting for input, it's just done. That's what it looks like, at least. So let's say that we are getting a halt, 99, or actually we're getting a... Let's see where we are actually halting this computer. I think it's in the parent, maybe in that one's parent. So if we are halting, then we are braking, and then if we are debugging, then we'll print halt. Program ended. And we'll run it again. And do we get halt program ended? Yes, so it really runs only for one single drone. And well, now it sounds like it's actually 2500, but it's not correct. And Crespel, you're saying you think each drone is independent? But like, what is... Yeah, that means you can do it in parallel. Yeah, sure, but... Why? Huh. Like, there's so little code here that I don't see where it could go wrong. I'm loading the right int code program, and I'm just getting zeros every time, or ones actually. Let me just read it again. When you activate the tractor beam but nothing happens, it's hard to tell whether it's working. There's an int code program that gives you access. It uses 2 input instructions to request X and Y, to which the drone should be deployed. Negative numbers are invalid and will confuse the drone. Then the program will output whether the drone is stationary or being pulled by something. Oh, I know. Oh, I know. No, I don't know. I was gonna say I know I'm passing strings or something, but no, my input is not what I'm going to pass to the program. It's the program itself. So at what point is it reading my input? Here I have 0, 0, okay. Maybe my relative base is not reset correctly or something. Let me check that. So I will run it till the breakpoint and then run it one more time. So now we have my console here, and this is the second run. And when we run it, like here, our relative base is 0, so it means our program is really reset correctly. But it looks like the second time I ran it, I also have inputs 0, 0. Let's run it again and see if we actually get 1, 0. And no regex, please. Yeah, okay, so for the second run it's like this. This is the first run actually. Okay. And in the second run our relative base starts there. So that means it doesn't work. Why is that? Shouldn't it reset the relative base? Yeah, it totally should reset the relative base. And I am not doing that. But when I reset the instruction pointer and relative base and waiting for input and the inputs also. And okay. Yeah, it's something that confused me many times, whether or not I should kind of reset everything or not. Now we have a list index out of range. Okay, I'm going to reset the relative base manually, like this. Now it's running. And what do we get? I can't read my output because of my nice hint. And I'm going to disable debug mode. And I lost my day. Okay. And so I actually had a bit of a bug in my IntCode program. So I again get 2500. And why is that? Why do I get so many new lines here? Halt program ended. It looks like it's actually ending straight away. Maybe I need to reset it even more. And to be sure that I'm doing it correctly, you know what? I'm just going to load the entire file. So load program, I think I called it. Load from. Load items from file. No, that's not it. I think I had a function to just load a file and that's it, and not kind of store it in anything. But doesn't matter. Just gonna do it like this. We'll run it, load it, and run it. It's very slow, of course, like this. And now we get 126 as an answer. Okay. And it's correct. Well, that was a bit annoying. But let's see. You're not sure how large Santa's ship is. And you aren't even sure if you'll need to use this thing on Santa's ship. But it doesn't hurt to be prepared. You figure Santa's ship might fit in a 100 by 100 square. The beam gets wider as it travels away from the emitter. You'll need to be a minimum distance away to fit a square of that size into the beam fully. Don't rotate the square, it should be aligned. Okay, so suppose you have the following tractor beam readings. Okay. So the 10 by 10 square closest to the emitter that fits perfectly within the beam has been marked with O's. Within it, the point closest to the emitter is the one highlighted here. Find the 100 by 100 closest to the emitter square that fits entirely within the beam. Within that square, find the point closest to the emitter. Okay. Let's think about that a bit logically. So the widest points are going to be the corners of the square, and basically we need to figure out the edges of the beam and figure out whether the corners are in it or not. Right? And we don't know if our beam is going in the same kind of direction as in this example. It could be different. So let's print our beam actually. So we'll print a hashtag if yes and otherwise. We'll print a dot with no line ending, and we'll print a new line also, and let's run it. So it looks, oh no, not if yes, if the computer output was correct. In beam. So if it is in the beam, then yes. There we go. So it looks like this. Actually, it's a much narrower beam than we thought. And can we actually predict how wide the beam should be at the position where we have our square? Maybe it's like half or something, but it looks like not. So let's say that our beam is like this. Then we have a certain square. It's funny, just drawing a square is not that trivial either. Like, I don't know where to go right. Although I can go right at many different positions. I can go here, but the square would just be smaller. But how big is the square going to be? At this point, I don't know that. I would know it if I would first kind of go here, I guess. No. What's the biggest square I can draw here, actually? I can try different sizes. So this one doesn't work. I can try a little bit smaller one. This one doesn't work. Try this one. This one is a little bit too small. I notice I'm drawing it a little bit at an angle. This is the right angle. So basically, it's a matter of finding a point on this line, the angle of the square, actually. That should be 45 degrees. That is less than the y, like that, less than the upper side of the beam, lower than this point. And unless you know the formula for this line, you are not gonna be able to know it right away, I think. So you can estimate the formula, of course. You can take faraway points and see where exactly it is possible. But, well, let's think about it in another way. Let's say we know it already and we have a square. Then that means, what does it mean? Well, I noticed some things. For example, that this distance is, let me change the color. The distance here is different from the distance here, so there's no kind of symmetry in there. What else do we know? We know that this is not the same as this distance. We can also not make estimates based on that. We don't know anything about the width. Well, we know it's larger than the square, that is for sure. We know it's quite a bit larger than the square, depending on how far we are away from the start. Because let's say we have a beam that goes mostly down and we're very far away, then the side that's sticking out, so to say, is going to be very small, but it's still going to be bigger than the square. So let's see how can we solve this. We can of course try everything, but we mostly should try the corners. And something else I noticed that if we have a beam here and our square is here, then you can see that the corners are very specific in that there are 4 positions and the one on the bottom left is filled with is within the tractor beam and the other ones aren't. So those are kind of the patterns that we need to look for. Yeah, that's it. So basically we can just move our square to the bottom right, and maybe we can follow it along on the bottom side. So here we're gonna trace the bottom and then see if the top side is actually correct. Okay, so that's what we'll do, and we'll have to start far away, but let's say we do it like this. By the way, I want to be able to run the program without loading it every time. That is so lame to need to do that. And maybe we can find where I actually made that load program from file. I made it here. No? Yeah, load program from file, that is the one. I'm gonna use that one from the AMP runner. So our program is here. We'll use it with this input. And I cannot find it. Maybe now. Yeah. And then we'll just pass it when we run the program, like this. Let's see if it's a bit faster now. Well, it's fast enough, I guess. Okay, so what are we going to do? We're going to, well, first of all, commit this. It's commit. I'm glad that this is a simple puzzle today. Day 19, part 1. And then for part 2, what are we going to do? We're going to try out a lot of things. Alex has solved the part 2 of the puzzle. I'm surprised kind of that people haven't solved it already. But, well, we'll see. So we have the ship's position and it starts at 0, 0. We're gonna try if it will fit. So we have an infinite loop that is going to continue, and so this is going to be the top left corner, and so the ship's bottom left is going to be the ship's x and y. So we have the x and y taken out of the ship, and the bottom left is y plus 100, that's the ship's size, and the bottom right, oh wait a second, I need the x also, and the bottom right is x plus 100 and y plus 100, and the top right is going to be the x plus 100 and y. Those are the four corners of the ship. Wait, four corners, bottom left, okay, top left also, and that is actually x and y. So yeah, I could inline that, but now I have all of those corners. And then let's say that if our bottom left is going to be empty, that means that we're a little bit too far to the left of the beam. That means we're here, for example. Then we're going to go to the right. And if we're in beam, wait, we need to know for each corner if it's in the beam or not. So the bottom left. Let's define a function that checks if it's in the beam. In beam, certain position, and that's it. So we can run the program with the certain position, maybe x and y, x and y, and then we'll return if the computer's output, first output, equals a 1 or not. So if the bottom left is in the beam, then it's fine. If it's not in the beam, then we're going to increment the ship's x position a little bit. So maybe I'll just keep x and y here as 0, 0 and not use a tuple for that. So that means that x is going to be incremented a bit. Alright? So my strategy is to draw a square, and if the bottom left is not in the beam, then go right until it is in the beam. And else, if it is in the beam, then let's check if the top right is in the beam or not. So if the top right is not in the beam, then we're going down a little bit. That's all. Until we found that the bottom right and the top right is in the beam, then I think we're done. And then we need to print the position, x and y. Okay. And we are not gonna render anything, actually. Let's run it. In beam requires 2 positional arguments. Oh yeah, okay. Like this, x and y extracting from the position. And in the meantime, I'm going to print the debug statement like this. Not in beam. Okay, actually we get an answer. And what value do you get if you take that point x and multiply it by 10,000 and then add the other one? Hey Alex, good morning. I see that you've already solved part 1. 1642. That's a big number. And I have to remove the commas from it. Ah, it's not right. Oh, okay. Let's return. So this was actually incorrect. Okay. And how was it, Alex? Was it as easy as you thought in the beginning, or was it actually a bit harder than you thought? I think it did take 20 minutes, although when I read the puzzle it seemed like something you could technically do in like less time. Not to put any pressure on you, but what part made it a little bit more tricky than it seems on the outset? Well, I'm reaching a tricky part now because I thought I had an algorithm that would work, but apparently it doesn't. Going down, no, going right. So if the bottom left is not in the beam, then I'm gonna go... but we start at some kind of weird position where we don't have a continuous beam, so maybe I want to start at somewhere else, like this position here. So it's like 1, 2, 3, 4, 5, 6, 7, 8 to the right, and from the top something like 0, 1, 2, 3, 4, 5, 6, 7, 8, maybe here or something, or maybe actually here. So that's 33 characters, so 33 to the right, and it has 50 lines, as we know, so I'll do 49. It was alright, you thought? You had a few bugs. You didn't know that you have to restart the program. Yeah, that's kind of the thing that took the most time for me also. And you had a silly index mistake, like -99. Okay, alright, so basically nothing intrinsic around the problem. That can happen, of course. Okay, this statement is not helping very much. X and Y is what we need. And now we get a different no, we get the same output actually. And going down. And of course I am curious to know if you solved it in the same way as I did, but I am not quite ready to take hints yet. This puzzle seems really quite doable. Let's rerun it. And I don't want to run this first program. I don't think I need it. So it is kind of going right, down, down, right, down, down, right, down. So it is about... yeah, it is about 1 down, right, then 2 down, then right, then 1 down, then right, 2 down, and so on. So it seems to be pretty consistent in the way it is going. But here it goes down twice every time and then 1. So okay, you cannot totally predict it. Multiply it by 10,000. And my previous answer was... I don't have it anymore, maybe I have it on my clipboard. My previous answer was this one, I think. Yeah, that was incorrect. Okay, maybe if we know for sure that... okay. Well, maybe if we are in the beam, we might still need to be sure that we're perfectly in the beam. So maybe we still need to go 1 left or something. Let's check that. So if in beam our bottom left position, but we're going to add to that, we're going to try 1 to the left of it. So that means at this point we are in beam, right? At least the corners are in the beam. But if our bottom left and then 1 to the left of that is not in the beam, I'm just gonna show it quickly what I'm talking about. So we have our beam and we have a square, but let's say it's now in the beam. Now I want to make sure that the position next to the square is actually not in the beam. That's what we need. And the one here on the right is also not, and the top actually also. I think we need to check all of those. Although this one can be in or out of the beam. Well, it is gonna be in the beam, it doesn't matter. And actually this one is the same case. It doesn't matter whether or not that one is in the beam, but this one definitely needs to be out of the beam. Otherwise we don't have an optimal solution. I think. So we're gonna check the one on the bottom left, and that is bottom left outside. That is the same as bottom left, and then -1 plus, and as a second dimension, vertically the same as bottom left. And the top right outside is going to be the same x position and one higher, like this. So if the bottom left outside is not outside, so it's actually in the beam, then we're going to move one to the left and continue. And if the top right outside of the beam is what if that one is in the beam? That means we're gonna have to go up. I'm not sure if I'm going to do loops forever now. So y would be -1 again. And then we'll continue, and otherwise we'll break. Okay. Print in beam now. But we need to go left a bit, and here we're in the beam, but we need to go up a bit. Do we ever do that? Let's see. No, it never happens. Oh, is it because I do break? No, it's not because I do break. Because I won't break if any of these cases are true. Maybe what I can do now is actually render the entire grid around it. Let me do that. So I'm going to go over the y's in the range of the x position. That should be correct, but I'm gonna do like 3 around it, maybe 5 around it, until x plus 100 plus 5. And wait, I'm saying x, that means I'm doing x, and I'm doing the same thing for y, like this. I think that's going to help. And then we're gonna print just as before. Oh well, we'll just print the output of in beam for x and y, and then we'll print a hash again if it's in the beam, and otherwise we'll print a dot. But if our ship is right there, then I want to print O's. You're gonna have to leave early. Alright, good luck with what you're gonna do, and thanks. And we'll see each other again tomorrow. Bye bye. So if we're in the ship, are we in ship? Maybe we can check that with a function in ship with a certain position that is happening when we have a y position. Hold on. Yeah, okay, I'm going to make a definition of the ship x and ship y, and the x and the y that we're interested in. And if x is bigger or equal to ship x, and x is, maybe I can do it like this, if x is in the range of the ship x until the ship x plus 100, then we're in range, but only if the y is also in the range. Ship y and shift y plus 100 that we can just return actually. And x and y are shadowing the other variables, but that's fine, it's only locally. So if in ship, now I cannot use here these names because they are already taken by the ship. So if the ship's x and y is like this and our x and y is like that, then we're going to print an O, no line ending, else we're going to print space. Let's run that. We get an error. In beam should take a positional argument. Okay. I'm not going to print all of this right now. It's a bit too much text and it takes too much time. So it's running now. I see we only have Alex so far that solved the puzzle. What's going on with the other people here? Are you struggling? Is it a lot of work or is it slow to run? I'm just fixing here my printing. It doesn't go exactly right. We should get output pretty soon now and have a little bit of a view of what's going on. So the ship is really big. You need to brush up your geometry and trigonometry. Oh, and I think I am outputting it a little bit incorrectly. Why is that? If we're in the beam, we're printing a hash, and otherwise we're printing an O. And I'm expecting the ship's coordinates first. Okay. But why do we get uneven lines? Why do we get bigger lines for the cases with the ship? Oh, I'm ending with a... oh man, ending with a hashtag for some weird reason. Well, I'm not using any trigonometry at all, and geometry not so much, just metrics. So we are in the beam right now, looks like that. And we're really quite deeply into the beam, and I'm not sure why it doesn't go up or down. So, and I would like to actually render the Santa's ship with a plus so that the difference is a little bit more clear in the visuals. So our bottom left outside is the bottom left of the ship, and that is the X position, and we're taking -1. And why do we not say that we're in completely that we're too much in the beam? I will actually break here and see what happens. I'll run it with debug mode. Maybe it's because continue is in an if statement? No. So, Crespo, you're using geometry to solve this puzzle? Why do you need geometry, or what's your kind of reasoning? I'm assuming that it's not going to be any spoiler for me because I'm taking a different approach that I think will work, but who knows. So we're now in the beam and we found the corners, and this is what we found before, right? 1147. Oh, hold on a second. 1147 and 1642. 1146. Okay. That means the X position is... Why do I get a higher number here? Oh, this is the BL outside, of course. Okay, so bottom the X is 1147, 1642, and the bottom left is 1 to the left, but why do I actually have a Y position that's so high? Yeah, that is actually fine. Your first instinct was to determine the beam angle and calculate the point at which the beam width is large enough. Yeah, that's something I considered also, but considering that the beam width that you need, like, I'm not sure, yeah, you need quite a bit of trigonometry to figure out how wide the beam should be, because it's wider than the width of the square, right? And the samples might not be precise enough. Maybe if you take very far away samples, like if you have an estimate, you could kind of try out samples far away and see if you can find the middle point. So the bottom left outside looks correct. And if we're in the beam there, then we're going to have to go to the left a bit. But why do we say we're not in the beam? It says we're not in the beam. But when we run the code later, we do say that we're in the beam. So we have X and Y, in beam X and Y. Yeah, actually, right, I'm actually rendering the ship's X and Y coordinates instead of the position that we're iterating over in the rendering loop. Yep. So now I'm sure that we're gonna get better, and here you see it. So the bottom left is actually perfectly within the grid, and except that we could go one up. We could go one up, but we could not go one to the left. So that is because our beam actually is very much going down rather than right. So we should try first to go up a bit. But why don't we go up? Because... wait, that is weird. We are still in the beam on the top right, so we should go up. But maybe what happens is that as soon as we go up, we decide that I'm not so sure why we don't actually do that. So I'm running it again with debug mode, and let's check out that corner. Still less than 1 hour into day 19 and working on part 2. I think I'm going to be able to solve it before the end of the hour. We're basically putting our ship on the beam, and if the left bottom corner is not in the beam, we're gonna go right. So basically we're gonna go right all the way until we hit it, and then we're looking at the top right corner, which should be around here at that point. Then we're gonna go down one step, and then in the next iteration check the bottom left corner. So we're basically moving left and right, moving down and right until we're completely in the beam, and then adjusting to see if we might need to go up again to kind of be perfectly within the beam. So it says that we're not in the grid, and I think the top right, I calculated that incorrectly. The top right is actually, no, that seems to be correct. Our top right is 1641, which is the same as our Y coordinate. Yeah, but it's just one less. And now our program is saying that this is not in the beam. And our top right corner is 1147. Maybe... I'm thinking if I'm having a off by one error with my ship, maybe it is a little bit incorrect. Let's say that our ship is too wide, size 2, then the ship's coordinates will be 0. On the x-axis we will have 0 and 1, right? And on the y-axis we also have 0 and 1. So we have only these 4 points. Coordinates 0, 0. We have 0, 0 and 1, 0. So here I'm checking if our ship is in the range. No, if the past position is in the ship, in fact. And I'm checking it like this, and I think that should really work. There's no bug there, but I'm still going to verify it. So if 0 is in the range of 0 and 2, we get true. And if 1, yeah, and otherwise we get false, right? What could be going wrong? So basically we have found a position, but when we render it, it looks like it's incorrect. We also do continue, and it says the bottom left outside. Oh right, I was going to do the other one first, and that is this question here. And we want to be outside, so if we're not outside, then we're going to have to adjust like this. That is what's going wrong. So if we're not outside, we're gonna go to the left. But I do want to go up first, like this. Now we're gonna run it, and this should definitely give us the right answer. Stop all. I don't know what just happened. I think I was doing some kind of profiling. We're printing everything in the X and Y coordinate. And we're in the beam, but we need to go left a little bit. And that means we're probably going to go in circles. I am going to use debug mode, and I'm gonna print the current state. Like print ship. And I'll put it here on the top. And our ship's position is X and Y. It is a global, but I'll pass it here. So if we're in the beam, we're gonna print it, X and Y, and we'll break. We break before we continue. So it's moving quite far, and you see it takes a long time, and that's because of that print statements just take a long time in Python. So let's say that if y modulo 10 equals 0, then we're going to print. So we're going to print it in steps of 10, maybe steps of 40. Run it again. And now I didn't do debug mode, excuse me. It seems to be slower than before. I'm not so sure why that is. Maybe something is still running in the background or something, but it doesn't look like it. And actually, what I can do is I can start with the value that I know to be pretty much close. So we can start with these two values. And then let's see if it works. Oh, look at that. Look at how slow it is. Wow. Also, what I can do in the printing is to check if it's in the ship, and otherwise check if it's in the beam. Yeah, okay, that's what I do already. I think my computer is like really slow. So hold on 1 second while I look what's going on. Okay, mostly Python that's taking up CPU and my dashboard. So maybe my dashboard is actually playing my video or something slowly, no? Okay, I'm not sure exactly why it's so slow. And it's also not breaking, which I wanted to do. So actually, it's not breaking, I'm not sure why. Because continue statements cannot be braked upon. So we are here, and it says we need to go up a bit. That makes sense, yes. We need to go up a bit. And on the bottom left, it looks like this. And what happens when we go up a bit? We should have only 2 hashes above us. So let's go for one more iteration and see how it looks. And we have now only 1 left, and we can do it another time. Wow, no idea how it can be that slow. Okay. Going up a bit again. And now, how come that we're actually now not where we're supposed to be? Is it because we're changing X and Y here something? We're checking the bottom left and the top right, and if those are not in the beam, then we're going to change something right away, which is fine. I think if the bottom left is not in the beam, then definitely that is wrong. But let's also print the location where we are. But we didn't. Yeah, okay. I want to keep these other statements right here. So we're in beam now, and let's say also where we are. % X and Y. Okay. We'll run it again. And we're starting now with the target location, which is almost perfect, but not exactly perfect. Because, well, actually I see that when I look at the output, we could just go up 1 more, and if we go up 1 more, then we'll have 1 more space to the left, and if we do that, and we would go up 1 more, it would work, and then probably it would be stopped. It would stop. So that is the original output, the original position that we started at. Now let's see if we're actually gonna go up. We're gonna go continue. And what happens now? We're printing again. We're now at which position? So before, we're now at 1149 instead of 1147, so that means we went up twice. Is that really logical? Maybe I missed one debug step. Okay, okay, so we went up a bit, and then it says 1148, we're not in the beam. So that means that the bottom left is not in the beam, and here it is, the top right is not in the beam. Well, I'm not sure if that's true. Let's print it. Print ship X and Y. Okay, and we run it. So the bottom left is no longer in the beam, it says, and we're gonna go right. So and actually I'm already incrementing the X so that when I'm rendering it, you won't really see it. You won't see it correctly. So I should really increment the X after printing it and then run it. And Nubali has finished part 2 as one of the very few today. Yeah, is it the case that perhaps people are getting very exhausted from Advent of Code and that we don't have as many people solving the puzzles anymore? The global stats do indicate that this day was a lot easier than yesterday, which I think is the case. We have more than double the people completing the Silver Star compared to yesterday. And yesterday, of course, has already had more than 24 hours, and the current task is only been 1 hour so far, and I'm going to be too late as of this very second to finish it in 1 hour. And it is getting to be that time of the year, and that is true. Christmas is coming up, of course. We have 6 days left, and family obligations and parties are gonna happen. So here it says that... Oh, hold on a second. So maybe I want to print the ship right here. Yes, that is fine. I'm going to print the ship after saying what we're gonna do, just to make it consistent. So here it says we're in the beam now, but we need to go up a bit. That is correct, I would say. And then, what does it look like now? We are breaking here. We needed to go up a bit. Okay. And then what happens? And then it says the bottom left is not in the beam anymore. Oh, maybe that's what's going on here. But it's not clear from our output. In my output, it looks like it's in the beam. But I would definitely say that it's in the beam, because this hash is in the beam and this one. So here must be a hash. Really, there must be a hash. Maybe I can actually render the parts that are out of the beam. But really, why do I say that my bottom... Oh, yeah, wait, oh man. Okay. Completely being confused about what I'm doing. So I know already that we're completely in the beam, right? But I want to know that the bottom left on the outside is out of the beam. And if it's in the beam, then we're gonna have to go left a little bit. And if the top right outside of us is in the beam, then we're gonna go up a bit. Right. That is what we're doing. Yeah, okay. So we need to rerun it. And now it's going to be correct. I saw a TED Talk some time ago. I think it was a TED Talk. It was about being wrong and being right. And it starts by saying, do you remember the last time you were right about something? And do you remember the last time you were wrong about something? And how did that feel? And now I'm not asking you the moment when you realized that you were wrong, but the moment that you were in fact wrong. And when you think about the moment that you were wrong, when you didn't realize it yet, the funny thing is that it feels exactly the same as being right. So the moment you're wrong feels the same as being right. And that is always the case. Unless you're unsure, of course, then it feels a little bit different. But it's interesting in these puzzles also that you can feel so strongly that you got the right answer, and then it turns out you don't. And then there was some kind of clue in the end about what to do about it, but I don't remember that part. So it seems like we're not breaking at all. What happens? What's happening? Actually, we're just printing the output because we're completely inside the beam, and that's it. Let's print our ship, X and Y. Maybe I multiplied the wrong values or something. I have to take the X coordinate closest to the beam, multiply it, and then add the Y coordinate. Yeah. So here is our final output, but we can actually go up, but we're not going up. And oh no, wait a second. Yeah, no, it's fine. If the top right above the ship is in the beam, then we need to go up. But for some reason we don't. And I don't know why. So here we are. Our top right outside is 1247 to the right and 1641 from the top. That is the right coordinate. And let's see if that is correct, if I'm thinking about it. Let's look here. So let's say we have a 2x2 square. That's the ship. And we say that our ship is at position 5. That means that this is position 5, kind of. And this is 6. And it's at position 5, 3. So it's 5, 3 and 5, 4. And we have 6, 3 and 6, 4. And this position here, which should be outside of the beam, I guess, yes. That should be position 6, 2, right? And we just can add 2 to the left coordinate. Or maybe we can't. Maybe that's just the problem. So to get the second position, the y, yeah, let's see. So the ship is too wide, right? And the left part of the ship is at x is 5, but the right is at x is 6, and not x is 7. So we don't do plus 100, we do plus 100 minus 1. So our right boundary of our ship is incorrect. That is really lame and hard to believe that I spent so much time overlooking that and not trying it out. And this is exactly, of course, what Alex was saying about 99 and 100, and I haven't considered it even. But on the other hand, I didn't take a hint, so I did figure it out by myself. But yeah, that must be very boring to see, guys. I'm very sorry if that was boring. Let me know if that was boring or if you didn't mind it. So we are now in the beam, but we need to go up a bit indeed. And did we go up a bit? We are now waiting here, and it says we still need to go up a bit. Let's keep going. And now in beam we need to go up a bit also. Doesn't seem like we're actually going up a whole lot, and we also don't go left. So we have one position to go up, that's fine, right? And we're printing also when we're going left. And did that happen? No, we're still going up. And the right top is... oh, let's see what happens. I think also our ship rendering engine might also have this problem. When we are in the ship, that is also not when we reach 99, but or when we reach 100, but 99 only. So here we're printing the ship, okay. Now, yeah, so we actually do need to do a few iterations because our initial algorithm was kind of incorrect. So we need to go up a bit, and now you'll see probably that there are going to be 2 hashes above the ship. And that worked, and it is very slow, so maybe what I can do is actually render a little bit less around the ship. Let me render only 2 on each side. That is going to save a bit of time. Still not entirely clear why my program is running so slowly right now. It might be related to the OBS streaming. So this is really a lot faster. That's nice to see. And we are braking, and we're saying, what are we saying? That we are in the beam and we need to go up a bit, and you can see here that we have quite a bit of up to go. Now we're going to the right, because the bottom left is no longer in the beam. That could be the case. It's not so clear, but it could be the case. And then after that, our bottom left should be in the beam again. But it still says that our bottom left is not in the beam. Okay. Ah, but if that's really true... If that's really true, then maybe we went up a little bit and then we're going right again, all the way until we hit something. And I'm not sure if we're actually going to get to the right place. So let's see. We need to go up now. Okay, that's fine. It's so big actually, you know. It makes it a little bit hard to keep an overview. Let's make it very small. Like this. And we're gonna go to the right. And I don't need to brake there. And we are going to go up again. So maybe at this point I'm just gonna keep it running, because I think it's probably going to be correct. As long as we're not going down anymore, then it's fine. Here it says that we're going to the right. Okay, maybe going to the right is fine, but I definitely don't want to go up. No, I want to go up, that is fine. But I think I'm going in circles, kind of. So we have a few of us who have solved part 1, and a few who have solved part 2. It's Fuzzy, Nubali, Hans, and Alex. And I think we're going in circles. So maybe what I can do is I can remove these I can move these parts, because I already have a position from where I can move the square, and I don't want to go to the right and down anymore. I just want to go up and left. Waves, yeah. Good job. I'm all here alone on the screen, so I cannot do a perfect wave. And why is continue not an okay statement here? We are in a loop, right? Continue outside loop. We're in a while though. And here's something that is missing. Okay. Let's run it. And now we're gonna go only up and left. So this is not a very clean way to do it. Like first go all, well, it is a clean way, but I'm doing it manually now. I went basically from the top all the way down until I'm fully in the beam, and then I'm going up again to see if I can squeeze myself in between those beam edges. And yeah, the rendering is just terribly slow. We probably wouldn't need it. Now we're in the beam, but we need to go up. But the left corner went already outside of the beam. And oh, hold on. Why am I saying that we need to go to the left? It's when the bottom left is still inside the beam, right? Then I need to go left. But it looks like we're going left over and over. And why is that? Because we're saying... No, we're actually saying that we need to go up. Oh, we need to go up so much that we keep going up. We keep going up. But how can it be that our left side is going to get outside of the screen? Outside of the beam? So... Oh, my webcam is dead. But you can still hear my sound. And it wasn't a very good location where it actually stopped. So I'm going to see if I can change that. Webcam dead. What can I do about that? Maybe, yeah, I know what I can do. I can try to change the resolution and see if that resets it. Yeah, that worked. Okay. No idea what is that. Maybe CPU usage or something. So as I say, I'm going up here and I have a few spaces left to go up. But as I go up, it seems like my left edge is going to suddenly be lower or to the left or something. So it feels like I say I'm going up, but actually I'm going to the left or something. How is that possible? Am I printing it wrong? I have X and Y and I'm looping over the X and Y. And I'm checking if X and Y is in the ship. Otherwise I don't do... I just print the hashes and the dots. I think I'm probably doing something very silly. So let's try it on an example. The original pro tip. We run it on a smaller... Let's run it on a smaller ship. So our ship size is going to be 100. I'll replace 199 everywhere with ship size -1. And we'll have a 4x4 ship, or 2x2 ship. And we'll start with the top left corner. So XY is actually 0, 0. And we're going to use our original algorithm. And so here we are in the beam. And I am going to... Oh, this is printing every now and then, okay, but I want to print every time. And I'm going to keep track of whether or not we've been fully in the beam. That is not the case until we find out that here we have been fully in the beam. And then we'll stay like that. And we'll only try going down and right as long as we've not been fully in the beam. So if we're not fully in the beam yet, and the bottom left or top right is not in the beam, then we're gonna go down or right. And otherwise we'll go backtracking and go up or left. Was that the intended variable name? Ship size declarations. Yeah, I'm overriding it. 100 is the default for the puzzle, and I'm now doing 2 to try it with a smaller ship and get a bit of a better feedback. Hi Denzei, by the way. So let's try that. And I'm rendering now very large distances. So let's do ship size also here. Oh, right. So our beam is so small that you actually never are going to be in it, or not very quickly. Let's see. Let's start again also on some kind of further position where we have a little bit more density. And in the example it was a bit over there. Well, let's see. Again, I have this problem. So my ship size is 2, but when I'm rendering it, I'm rendering only 1+. So that means that my rendering function is wrong, because that is using the ship's actual size. And here I'm doing -1, and ranges don't include the last digit, so I didn't need to do -1 there. And here it says we need to go up, but then when we go up, we go to the left. I've double checked that code like a million times already. So it says we need to go. We're in the beam but we need to go up a bit, and then when we do that it looks like we're not going up, or maybe we did go up. We did go up actually. And then when we went up, the bottom left was no longer in the right place, and now it's kind of not doing anything. What happened? Are we are still running, but where are we? I don't see anything happening. So let me rerun it again. So we start out fully in the beam, and let's render a little bit more margin. Margin is 10 instead of 2. Well, there we are in the beam. Okay, and now why don't we actually go up? Oh. So the bottom left is... Okay, the top left is the X and the Y. The bottom left is the same with the ship size added to it. Bottom right is the same with ship size added to it and Y also. And here I'm saying the bottom left is not fully in the beam. We're going right, we're adding 1. That is correct. Hey Emily, good morning. The top right is not in the beam, so we're going down. We're adding +1 to the Y. And here we're looking at the top right. That is the first one here. And we're taking the X value of top right and the Y value of top right -1. So that means we're 1 higher than before. And we're saying that we need to go up. Oh man. Oh man. That took me forever to notice. I am going up by subtracting -1 instead of 1. Damn. Excuse me for cursing. That was definitely half an hour of time or more. So now it should work. Let's run it. Those are the little things, you know, you can be so smart and have nice algorithms, but if you're not careful and make just a careless mistake, then you're still going to be stuck forever. And this looks like it's actually trying to go up left correctly. It takes a long time to render because of the margins that I took. Oops, just locking my screen here. Let's rerun it without debug mode. And now it found a space, but we can still go up. And we did go up probably, but we don't print the ship in the end. Or do we? No. Actually, at this point, it seems like we say we need to go up a little bit and we're fully in the beam, but if we didn't continue, then we just need to break, so it means we found the answer. So this... hi everyone, our stream just crashed and I have restarted. I hope that you're all still connected. Excuse me for that. But we have found now a solution, and all we need to do now is to actually use the right values. So the right values means that our ship is 100 long and wide, and we can run it now on the full input. And I'm thinking maybe let's not print the full output every time, because it is very slow. So we don't print the ship at all, like this, and we'll run it. And we run it now at the very end. We have a solution that looks correct, and it is these numbers right here. And I can just concatenate them and submit it. And it says that it's not the right answer. So I'll keep it here in the list of things I've tried. Let me see also if I have 100 characters selected, and it does look like that. And if you look here at the bottom left, it says that we are already outside of the beam. So why can we not go any further? We could actually go up, left one and up one, and it would still be fine. So maybe if the one above the bottom left outside is available, and the one on the bottom, the top right, and then, oh man, I don't have any name for that, but there is another position that we can try to go to. So that is going to be called top right outside 2, and that refers to this position. Oh, actually that is basically from the top right going up left a little bit, and from the bottom left going up left. So that means we're going -1 on both of the axes. So if we do that, then if we have this case, then we can actually go up and left. So if the top right up left is in the beam, and also the bottom left up left is in is in the beam, then we can still go up and left. So x -1 and y -1, and then we need to continue, so we don't exit our loop, and we don't print the ship in beam now. Let's skip, let's jump up and left by 1. There we go. And we did do it. Let's jump up and left by 1. And now we're really far. And now we have another answer. And I might need to wait a bit. Let's see, that's also not the right answer. It's too high. Oh man. But this is the lowest answer so far. Does it mean that we can actually go left and up twice or something? We cannot. Yeah, we can. Oh, okay. So that is another option. Maybe there are like an infinity amount of options, but I don't think so. I think this is probably the last case. So it means up twice and then left. Go up twice, then we're going to jump up 2 and left by 1. So up 2 and left by 1. And we rerun it. And did we actually use this piece of code? It doesn't look like it. So maybe I didn't define it correctly. So up left means going 1 to the left and 2 up. And here we see that we are using it. And then we might have finished it. Now, let's try it again. Hey, good morning, G. You just woke up. And you're right in time to see me solve the part 2. That took a bit long. There are actually a few edge cases that you need to look into. So can we actually run it now all the way from the start? I'm curious about that. Yeah, that was pretty... It was kind of fun. I like the puzzle actually. I just didn't like being stuck on something so dumb as subtracting a negative number and not realizing I'm going down. If you see me do something like that, please do point it out. I don't mind it. I don't mind it. I don't consider it a spoiler. So that would just make the stream a bit more fun, and yeah, then we can focus actually more on the puzzle. But of course, carefulness is part of good programming, and it is extremely important in solving puzzles. So I think I'm going to take that as a lesson, and when I write a statement, I'm going to double check it every time I write it to be sure. So now we have the right answer. We started out going all the way from the start, well, not exactly the start, but just some position that is going to be in the beam. And then after we went all the way to the right bottom where we are in the beam, then we're going to trace back and try to squeeze ourselves as tight as possible between the beam edges. And that's how we solved it. Okay, I'm going to commit this, and then let's look at some other solutions. So if you have a solution and you think it's interesting, or maybe you think it's not interesting but it's just different, I'm very curious to see it. Just go ahead on Pastebin or Pasteboard, GitHub, Gist, and paste your code there, and we'll have a look at it. And I read Python, but I also read other code. I also read Crystal, I read Haskell and Java, Kotlin. I can even read C. I don't know C, but probably when we look at it, we can still learn something from it. I'm going to commit part 2. Added the answer for part. Here we go, part 2 completed. And again, I have to commit twice. I'm not sure why. Sometimes even 3 times. Sometimes 4 times. Now it is committed. How about some other people on the board? So we have Nubali. Nubali, are you still here? If you're hanging out here, maybe we could have a look at your code. If you don't mind, if you're uncomfortable with that, of course, you don't feel pressured at all, because there are other things to do as well. For example, solving day 19. Solving day 18, on which I'm still working. So I am going to start with day 18 then, because I was working on quite a nice implementation of solving the maze, and the implementation was about trying different key orders rather than just walking around randomly and trying to calculate how far we are. So what I did is I am reading the example input. I have a distance function, I have some heuristic that I'm not going to use for now, and I have my list of nodes to visit for the A-star algorithm, which I'm also not going to use for now. And this is what I visited, but which I'm not using. I have the boundaries of the grid, and then I have a function to print the maze. That's it. And now I'm actually going to do part 1, and I'm going to store all of the paths to all of the keys from the center, and also for every key which doors are on the way. Those are going to be the dependencies. And I have a function that gives me the shortest path to a goal while ignoring the doors. And that is just a little breadth first search, and it is very fast. So after we have defined this function, we can go over every key, get the shortest path for that key, and we save it into the paths like this. And then afterwards we're going to keep a list of the dependencies for that key by going over all the path elements to that key and checking if that path position is actually in the list of doors. And if it is in the doors, we're adding the lowercase version of that door's name into the key's dependencies. And that is it. And then what I was going to do is I'm going to start with a simple strategy of just trying to get every key. Well, we'll see about that, how we are going to define our strategy. And Numbali, you're saying you're not sure if you followed how I did it or whether your solution is the same. Well, we can have a look. I'll read your code and we'll see if what you were doing was different or similar. And so there you are, you have pasted your link. Thank you for that. Very happy to receive some code and to look at what other people made. It's never been the case that we didn't learn anything from someone's code. I'll just copy paste everything here, then we can run it actually into a new Python file. So in your Python, whoopsie, what is this? I have copied also the line numbers. Okay, what can I do to solve that? Select it from the bottom. Yeah, there we go. So you have your int code class right here, and most likely we don't need that, so I'm going to minimize it. And my editor underlines it in red when I minimize it. And you're mapping all of the input, you're splitting it into a list of integers. No, I won't go over it, and I haven't looked at int code computer ever since day 9, I think, because it doesn't really change anymore, right? And so you have solve the first part. And how does that work? Let's see how you run it. You run it, you define solve, and then you have run test x. And I want to see where you actually run solve, but you don't run it anywhere. I guess you removed that to be a little bit faster, so I'll just call it somewhere. So let's call it right here with G and run it until there. And that is not your code, that's my code. And then probably I need to change the input file name. Yes, day 19 input. Let's rerun it. So I am assuming that right now it's running. Yeah, it did. And you did calculate the numbers correctly, and you're printing the beam. That looks pretty nice. And I guess it's the same beam as I have, but I'm not sure. Well, no, it must be the same beam, of course, because it's running on my int code computer. And let's see how you do that. So you have M, that's some kind of big list, and you have your int code machine, and you're trying all the x's and all of the y's, and for every position you're resetting your machine, and then you're giving it two inputs. So far it's the same, and then you're running it and you're getting two outputs out of it. And I'm curious what your machine outputs. Let's go to the end. It returns out and the last opcode, which is halt. So I guess you're using this second parameter to know if you're actually requiring input or if the program has completely halted. And I do see that in the background the code is still running, so I think I didn't actually break. Oh well. So then you have your output, and if it's 1, you're appending a hash to your row, and otherwise you're appending a dot. So you're basically going over all of the positions, and otherwise it's an at and a net. I think that would never happen, in fact, because the int code computer is programmed to output only ones or zeros. But you could use it to kind of make sure that you're doing it right. And then you're using M. So M is actually the matrix of your grid, and you're using small m's for the rows. Yeah, it's quite straightforward, except M. Yeah, I'm not so used to reading code with short variable names, like single letter variable names. So that took me a little bit of time to realize, but other than that, it's pretty much the same as what I'm doing. So for part 2, you have a defined function called run tests, and I see that you are using it. And you're always bad with variable names. And does it mean that you want to be better at it, or is it more that other people are complaining about it and for you it works completely fine the way you're doing it? Because some people don't really bother too much, and they are happy to use just single digits or single letters. Especially in mathematics, it's also quite common to do that. And if you're doing a lot of algorithms, then it's also a bit of a balance between long variable names. That means that you're focusing very much on your variables and less on your operators. You're saying if you're writing code that you're not planning to show to anyone, then you're just using a single letter variable, right? Yeah, and for me, I would do that if I know that I'm not gonna read that variable many times. But if your code becomes very complex, then it can sometimes help to make a little bit more clear variable names. Okay, so part 2, you were having an S that you're not using. You have your int code computer and you have a Y and an X position. I guess that is the bottom right. No, that should be the bottom left of your spaceship then. And you have a double loop. You have a few loops actually. So the outer loop goes on forever, I think, because I don't see a break on the level of the outer loop. So probably it runs forever, and that means I'm going to stop the code here also. And so, or unless you have a return statement, but I also don't see that. And you also don't have an exception. Okay, so this runs forever. And then first you're going to do something. You're going to give it the input and the output and checking if it is in the beam. And if it is in the beam, you're breaking your loop. So that means that you have already moved to the right far enough to be in the beam. And if you're not in the beam, you're going to move right a bit. You're saying it just stops at input when it's supposed to give answer. It doesn't seem to give answer with your input though. Okay, interesting. That could be because the position you're starting at might not be working for my particular ray of light. So my particular ray of light goes like this, and well, I'm not sure. You're expecting kind of to be outside of the beam, which is the case, and you're going right until you hit the beam. So that first loop should definitely work. Let's see if that works. And I'm going to not solve part 1 right now. That's also interesting actually, to see if your code runs on other people's input and to see if your solution is generic or not enough. And your beam went down at a much higher angle, and that means that you start inside the beam. Is that what you mean? Or you mean that the beam goes really much more like horizontally? So we did finish the loop, and X is now, what is X at the moment? I don't get, yeah, it's 66. That first part of the loop is just to find the border of the beam. Yeah, that's what I figured. So you're going to the right until you hit the beam, and then. Oh, but you're saying it starts at x0 but x100, right? Yeah. Yeah. So now it found the beam, and then we're going to do something else. Probably, I guess you're going to try the top right corner of the square and see if that hits the beam also. So you're feeding it x and y0, and that is the y position, which starts at 0. Oh, no, it starts at 100. And then if, okay, if y minus y0 is 99, and here you're subtracting -1 each time from the loop. Okay, it looks like you're kind of looking at the entire right side edge of the spaceship. I'm not entirely sure, but that's what it seems. When it finds a border, it goes right up at the y-axis and sees if it can go up 99 steps. So that looks like this then. I'm gonna show it visually. So we have a beam and we have a square right here, and we went to the right until well, you're tracking the bottom left corner. That's how I would see it, at least. You're going right until that one is in the beam. So now we're in the beam, and then you're going to look at the x. What is the xy? The x position is 0. So you're going to go up from there to see if that one can go up 99 steps. Is that right? But Oh, what I would think is you need to go right and then see if you can go up 99 steps. No? Oh, sorry, my whiteboard was not showing up. So then it checks if it can go right on the x-axis 99 steps. Ah, okay. Yeah, but you're checking the left border, aren't you? So you found the left border and then... okay, let's see what is actually here in this piece of code. So we start out with 0, I think, because y is 100 and y0 is the same. So on the first iteration we start with 0 and we're running the test. So we're doing 100 steps and we're going over the x-axis indeed. And Crespo, you were reporting the wrong corner. So sorry to hear that. How long did you spend on figuring that out? Yeah, this particular puzzle seems very prone to kind of slip-ups like that. Same as I did. So you're checking also if you're at the... Wait, A is actually the result, right? Okay, so that means we're outside of the beam and then we're returning 0, otherwise 1. So we're checking if we're outside of the beam, yeah? If any part of that X range is out of the beam. Okay. So we went... Please correct me if I didn't get it right. And also, if you feel like explaining it on the chat, by talking, we can also... I do have Discord. And then you can just kind of explain it verbally. Might be a little bit more simple. But I am going to try to figure it out. So we went all the way to the right until we found a position where the bottom is in the beam. And then we're going to... let me use a different color. Then we're going to trace all of the X positions, right? Or are we actually going to keep X position 0? No, we're not. So we're going to test all of these, right? And then we know that if we actually were not in the beam, so it means that we're probably too much up. Let's say we're here. So we're here, then we're not in the beam. That means we're gonna go... Ah, now it makes sense. Maybe it makes sense. Okay, and then actually what we're gonna do is we're gonna go right again. Right? So y-1 is going up a little bit. And here y0 is going up a little bit. So if you're going up a little bit, does it assume that you were already too low? So you're basically trying out to move the spaceship to the right until the bottom left corner hits the beam, and then you know already for sure that you're too low, so you're gonna go up. And so y stops when it is still inside the beam, but which corner actually are you testing that is in the beam? Y is 100 and you're testing if position 100. Yeah, okay. So maybe you're testing the top corner of your... Maybe are you starting at position Y is 100 and this represents the top corner of your spaceship, or are you starting at position 00 and this represents the bottom of your spaceship? That is something I'm not very clear about. I might be able to tell from the way you output the solution, and you're outputting y0. So y0 is the top left corner. Okay. Okay, that's something I didn't realize. So, XY is the bottom left. Okay, but if Y0 represents the top left corner, then Y, is it equal to Y? That I don't really get. Then it means that you're still moving the ship, kind of. Okay, I'm going to give it a final go, and if I can't figure it out, then I might need to get you on the call, or you do have to give me a bit more clues on the chat. Because I think probably your algorithm is indeed quite simple. It looks simple, and it is probably similar in spirit as mine. Basically moving around the ship until you hit the beam, and then kind of going up as long as you can until you're no longer in the beam or something. So it stops running from the bottom left corner, XY, to the right top corner, X0. Okay, yeah. Maybe we could... Oh, it starts running from the bottom left corner to the top right corner. Okay. Yeah. Can we print it actually? Do you have a way to print it? Yeah, you do have a way to print it here. Maybe we can actually print the positions, but some of those tests are in here, so I wouldn't be able to print that. Yeah. Okay. Thank you very much, Nubali, for sharing. I'm sorry I couldn't totally figure out how it works. You're saying that it sees if it can go 99 steps, and then it goes from the top left into top right corner and checks if it can go 99 steps. Okay, well, I guess that 99 up and then 99 right. Okay, and if you can do that, that means that you are completely inside the grid. And what happens if you cannot do that? What happens is that you're just going one down, right? And when you go one down, then you first need to make sure that you are that the bottom left is in the beam. So you're going first one down and then moving your ship all the way to the right until you're in the beam, and then checking again both kind of sides of the entire ship, like the bottom side and the right side, to see if it's completely in the beam. Yeah. All right, I think I got it in the end. So thank you for that. And now we're going to look at Crespel and see what he made. I'm saying he, I think you're a he, but I'm not sure. Copy link. Day 19. Okay, so we have Crystal Code again. And by the way, Crespel, your name is so similar to Crystal that I always tend to mispronounce it. Is your name related to Crystal also, or is it just a coincidence? So let's see how you do it. You use iterators and you go over... Okay, you go over each position in X and Y and you check the point. And for that you made a specific function. Hey Arcanian, good job for finishing part 2 also. And now we see actually a lot of people coming in finishing part 2 for today. And this special checkpoint function is using a clone of your VM. That's very handy. So instead of reinitializing it as I do, you just clone it. And this function is doing it like this. It sends an input and you're using very intention revealing variable names and also very close to the problem. So your VM is actually a drone, which is something I kind of forgot from the moment that I needed, and that I realized I was just going to check pixel values basically, or positions. But I think it is always good to keep your code definition close to the problem, like the problem language, because I do tend to make mistakes when I go too far away from the problem. And this happened in the asteroid puzzle, where we had to figure out which asteroids were blocking each other, and I called them asteroid groups instead of asteroid directions, and because of that I didn't realize that I was grouping too many asteroids in the same direction. So stay close to your problem domain. So we're sending 2 inputs to the drone, and the drone is gonna run, and then we're returning the output or 0. And not sure why you do that. Maybe it's for casting, or maybe it's for cases where you don't have an output and that you still want to output something. Maybe you could clear that up. It's just a bit of Ruby or a Crystal syntax that I'm not sure about. And so yeah, and then you're counting the hits, and if it's more than 0 you're printing a hash, and otherwise it's a dot, and then you print a map. Output could be nil, and Crystal will fail to compile if you try to do math on nil values. That's right. Now why could it be nil? It could be nil because read output is a part of your VM, and it doesn't necessarily always return something. That makes sense. So this first part I think is quite straightforward. And then for the second part, you're following the southwest corner, so that is the bottom left corner. That is the same as what I was doing, I think. Let me look again, I already forgot. My short-term memory is not very good anymore since that I'm doing Advent of Code. So I am tracing the bottom left also, yeah. So you're doing a checkpoint for this particular corner, and you have here X and Y, where Y is 50. Does that mean that your ship's size was 50? No, it doesn't. Y50 is actually the bottom left corner of the grid and not the bottom left corner of the ship. Oh, you need to check only the corners. Yeah, and that that is something I realized by just drawing it. If you're just drawing the shape of what it looks like when you're in and when you're out, you realize that basically you only need to look at the corners, and that's it. And the funny thing is that the top left and the bottom right corner are always going to be fully in the beam. They're not going to be edge cases, so you don't need to check them. And that's of course knowing that the beam goes to the bottom right. If it went anywhere like in arbitrary directions, then you couldn't use this tricks and you had to do something else. And 50 is just a random value that's safely outside of the beam to start working from. Yeah, so it represents the top left corner of your ship, right? And so as long as you're... Oh, it does also represent the bottom left, so it's the bottom left corner and you're starting. That means that your ship is actually going to be outside of the grid partially, so the top right corner is going to be at -50 and the right is going to be at +100, which is still in the grid. But as long as you're checking the bottom left first, it's fine. So as long as your bottom left corner is not in the beam, you're going to go to the right. So you also have a double for loop. I didn't have a double for loop. I did cases so that I would first check X and then I would check Y. So that's a difference in implementation. And then you're checking if the point... Oh, okay. If the right top corner is inside the beam and the bottom right corner is in the beam and the top left corner is in the beam and the bottom left corner is in the beam, then you're going to break. So if all of your corners are within the beam, you're done. So now that's interesting. You need to make sure that you are actually going to find the first possible location in the beam and not the second, because the way I was doing it, it might be the case, at least I thought it might be the case, that I would end up a little bit too far inside the beam and then I have to trace back, but maybe that's because I didn't take enough advantage of how the beam works. So your beam is always going to be sloping a little bit more in one direction than the other. So for example, it's going to go mostly down, or it's going to go mostly to the right, like this. And that means that your edges are going to look like this, for example. And in this case, the edges are going to look like this. So what you need to do is if you have a square and you're moving it to the right, now you're in it, but you're not really at the right. Yeah, actually you are in the earliest position, I think. So if you go right to actually be able to be in the beam, then it's fine and you don't need to go down afterwards. But if you are having this kind of beam and you're going up first, let's say you're going up, then at some point you're going to be up in the beam where you're like this, but it doesn't necessarily mean that it's the first position in the beam where you can fit, because there might be another case where you could fit here. And I'm just thinking, can you make sure that if you're tracing a beam that you're always going to be fitting in the very first position and not in the second position or something? You're saying you never go up, only right and down. Yeah. So maybe my algorithm was way too complicated. So what I did is I basically I start somewhere where I know that I'm not in the right position, and then I'm going to the right and I'm going then down. So I'm going all the way to the right until I'm in, like this. And then I'm going down, which means I'm just going down one step. Actually, I'm not going all the way down. So I'm going down a little bit and then I'm going right again. For some reason, I thought that I might not be completely, that I might have to trace back, but maybe I don't have to trace back and I just had a bug in my implementation. So let's see if we are actually tracing back in the end. So here's running the whole thing. And it takes a bit of time. And actually now I do find out that it's not tracing back. Because when it's tracing back, I have a special statement for that. It says we are in the beam but we need to go up, and we are in the beam but we need to go left. And so it's not tracing back, and my traceback logic was not needed if I didn't have off by one errors in several places. Okay, interesting. Then it means I didn't understand the problem correctly, but now I do. So thank you for that, Crespol. That helps me to get it right. So that's basically it then. So you're just shifting right and down all the time. And do you think, in general, do you think that you need to think clearly about whether you go right first or whether you go down first? Does it matter? Would it still work if you are going to do it the other way? And does it depend on the angle of your beam? Nubali, you think Crespol has the same logic as what you do? You start with the bottom left corner, right? From what I can see, that's what it looks like indeed. Yeah. Okay. Is there anyone else with a different type of solution, or who would like to see how you do this in another language? Nubali, you're saying it's much clearer code. It looks clearer to me. At least I can read it a lot easier, and I'm thinking, why is that? Because I was going to suggest to you, Nubali, that you could use, for example, a range instead of while loops. So for me, range loops are easier to read. So let's say you want to go from 0 till 100, then you can do, of course, break breaks, but you can also do for x in range 0 till 100, and then you know it's going to repeat 100 times, and it's also clear that what the possible values for x are. So that's just an alternative to writing a while true with an x is 0, and then doing like x plus 1, and then if x is 100 that you would break or something. Oh, you first did it with range loops, but it ended up being wrong. Then you changed it into that. Ah, okay. Alright, then maybe that was not a helpful suggestion. Yeah. Yeah. Okay. Any other code? Please feel free to share. You see that we're online with around 5 people that are on the leaderboard. That means there are some people who are watching but not on the leaderboard. If you want to join the leaderboard up here, then you can join with our join code. I'm going to copy that right now. One second. So this is our join code, and if you enter it on Advent of Code, then you are going to be shown on the leaderboard. And I can also make sure that your name looks like your Twitch name rather than your Advent of Code username, which might be anything like your GitHub name or just a chosen alias. Alright, I don't see anyone raising their hands, so then I would like to continue with my puzzle of day 19. So thanks everyone for watching day 19 today. I'm going to continue with day 20 tomorrow morning, of course. Do follow me if you want to be notified that I'm going to be live. Of course, I also appreciate being followed. And if you want to give me any suggestions for the stream, I'm very open to anything that you think might be interesting. There are definitely some days that we haven't discussed very much because of time pressure and lack of time. So if you want to talk about a particular day, also do let me know and we can make some time for that. After Advent of Code has finished, day 25, we still have a lot of time. We can go back over older puzzles and do a kind of review of certain very tricky ones. So do think about that and let me know in a direct message or on Twitter. I'm at Anagon Live, and also message me there. So see you again at day 20. And if you want to keep watching me solving day 18, do stay on the stream, of course. See ya. So continuing on day 18. My strategy was about deciding on which keys to get first and then which keys to get next. So visually that looks like this. So we have keys A, B and C to find, and let's try different strategies. And the first strategy would be to get A first, the other one is to get B first, the other one is to get C first, right? That's it. And then from that point on we can really just get A and then decide, are we gonna try to get B or C? We don't know yet. We're actually not gonna think about it at that point because we want to not think too much. We want to first see if it is a better idea than it was for B and C, for example. So our first strategy is to look at all of the keys that don't have dependencies. Of course, this is very crucial. And to know if a key has no dependencies, well, that's easy. We just have a dictionary for that already. And so our first strategy looks like this. Our first iteration looks like this. Let's run day 18. And it says not enough values to unpack because I am appending a tuple with 3 items. And I'm extracting with 3 items, but where is it going wrong? It's going wrong in here. Key dependencies is a dictionary, but to iterate over keys and values we do have to address items from it. And let's see, we just printed strategy, and the strategy is to get key C, and we haven't found anything yet. So to go to key C means we actually need to calculate how many steps it took to get there, and that will be important for our cost function. So our cost function right now is the length of keys. I'm not sure if that is the right cost function. We're not optimizing the length of keys, we're not trying to have as little keys as possible. So let's use a cost function like 0. That is how many steps we've taken so far, and we need an estimate, which is going to be none for now. And remaining cost is here, and we'll also have a total cost, and total cost will be on the left. So I'll start with 0, 0 and none, like that. And then we are going to look at different options. So let's say that we went to the key. So that means that we have to find a path from our current position. And that means we also need to know our current position, right? Unless, of course, we're going to do it in a bit of a different way. Well, the cost of trying key A first, yeah, that is definitely going to be related to the number of steps we've taken, because that is what we're optimizing for. So get the shortest path from our current position to the key position, and the key position is in the keys, like this. I'll extract it. That's the next key that we're going to look at, and our current position is something we need to know. Yes, we do need to know it. I'll add it here just before the keys that we have found. So our player position, that is what we are going to use. So we're getting the shortest path to the key, so that is called the key path. And didn't I actually keep a list of that? Didn't I keep it? I think I did, so we don't have to calculate it. But unfortunately the key path is starting always from the center point and not from where we are, so we do have to calculate it first. So key path, the number of steps that we took is the length of the key path. And that means that this is going to be our new cost. And that means that if we're going to try different keys to find, we are going to have to add the current cost for them. And the remaining keys I'm also interested in. The next keys, what is that going to be? That is all of the keys that we know to exist. So key for key in keys. And we need to know their positions, but we can actually extract them later. So let's look at only the values. But we don't want any keys that are already found, so they're not in the found keys. And we also want to check only the keys that have no dependencies left. So why does this not work? Key for key in keys values, if not key in found keys. And found keys is just a list. And also there are no dependencies. So the key dependencies are stored in key dependencies. And some of those dependencies might be already resolved because we have those found keys. So let's calculate the key dependencies that are still open. Key dependency or key dependency in. Let's see if I can autocomplete that. Yes, in. And that's going to look a little bit unclear perhaps. So we're checking all of the key dependencies and only those for which we don't have a key yet. So if key dependency is not in found keys, like this. So these are all, just double check that, don't want to make a mistake by accident. Maybe I'll extract that into a function to be a little bit more clear. Actual key dependencies for a certain key with found keys in it, and then we'll return that. Yeah, that makes sense, right? So we're checking what keys do we need to get that key, and that's looping all over the dependencies for that key, except for those which we already have keys for. So the keys should also not be in the actual key dependencies for that particular key, having found these keys. And what we should not forget is that when we decided to go to a certain key, we have also found that one now. So it is our new found keys. That is going to be the current found keys, and to that will be appended the next key. So we're not going to go to any key that was found and not to any one that still has dependencies open. And do I get a highlight? Why is that? Because it doesn't fit, maybe? Maybe that's why? No. Yeah, that was actually the reason. And this is not key in is not correct syntax. It should be not in. Alright, so these are all the next keys that we could be looking for. And then let's loop over them. Wait, you know what? I'll call it a target key instead, so that I can use next key as the name for the key that we're going to explore in next steps. Alright, and then we need to add a strategy. So we have our strategies, and we're going to append to that something with a lot of parameters, namely one for each of those. And I'll write it on a new line. So it is going to be the total cost with the steps that we have calculated so far. No, that's not true. The cost is going to be the steps. Well, that is the new cost. So we are using new cost. Remaining cost we don't know yet. We have no way to estimate the remaining cost. And we have a new target key, that's next key. And the position where we are is going to be the position of the key where we went. Key position. And we have found keys, and that is going to be the new found keys. And that is the way we do it. So now we have implemented a breadth first search for trying out all kinds of key combinations, and we are just doing breadth first search. We're not using our cost function at all yet, but that is something that I do want to do later. So let's first see how breadth first search works. And I want to print where we've been, and I think we need to know that. Well, we don't technically need to know it, but it is nice for visualization. So let's keep also a path, and our path starts with the player. So when we extract it, we have a path here, and let's add it to the end of the list. And that what we add is actually the entire path of the key where we went from the previous path. Now get shortest path might actually include starting position, and that is something I might not want to keep, because that means that we're going to have both the start and the end twice in our total path. So I want to actually take everything except for the first position. So that looks like this. And now, why do we get so many red lines? Probably there's something different about my length. No. Can't assign to function call. I'm assigning something somewhere. I'm doing plus equals rather than just a plus. Okay. And we get an unexpected argument also. So we should append actually a tuple and not call append with many arguments. Like that. And why? Yeah, now it looks fine. So let's print the strategies that we have on our to-do list. For S in strategies, and then let's just check only the first 10 or the first 3 and print them like this, maybe like this. Well, I'm not sure if that would work. Maybe like this. Okay, and we'll run it until we get the print statement. Key error 1.1. Where is that? When we are calculating the actual key dependencies, then we will have a key error because we're passing into it a position rather than something else. And the actual key dependencies takes a key, but we should take the keys and not the values actually, like that. And I need to go offline for a second. I need to ask something important and be right back. Thanks, Crespel. I do tend to forget that after interrupting my stream. I do need to find some way to remind myself. Maybe I can highlight something on the stream if it's muted. I don't know. Anyone with streaming experience knows how you can know when you're muted? That would help. Let's see. Yeah, so these are the available strategies. The first, the top 3 strategies to choose from, and we're going to pick the one right here, which is the one where we're going to that one. So actually, I'll just write it like this: getting key X, and we have several keys left. Keys available. And what else? Okay. Maybe I also want to have the available keys. But only the available keys after we find that one. I'm not sure yet. Maybe, maybe not. Let's just run it like this and see if this is clear. So I ran it apparently till the end. So we first started by taking key C, then we decide to take key B, but it looks like we didn't actually keep C in our strategy. So it means that we didn't actually save it, or it means that, well, it was appended to the end of the list, and so we don't see it. Maybe if we print everything, it would be a little bit more clear. So you can see we start with C, and then afterwards, well, we're not appending anything. So it seems to look like we're not able to find anything after taking key C. Is that possible? So we're taking key C, and then after that, well, we should have key C, right? Nothing is ever being appended. Okay. So our newfound keys is expanded, and the next keys. So here's of course a lot of things that can go wrong. Let's break here and do some evaluations. And I must say, I don't know what's wrong with my Python. It seems like it doesn't actually want to break. It doesn't break a lot. And maybe there's some kind of setting that says that don't break on anything that's not a statement. Settings. I don't see anything here. But do you also have this problem where you're putting a breakpoint and you're running it and it actually doesn't break? Like, it's really strange. If I run this, you see it actually doesn't stop here. And I don't know why. I think it has caused me a lot of confusion. So our newfound keys contains C, and we want to know all the keys that are not in the newfound keys. So that part looks like this. But we have to put something around it. But that is actually everything except C, so that part works. Maybe I'll extract that one into a variable called we cannot perform refactoring. Okay, maybe that's because, why is this? Oh, because we have two. Okay, we have two conditions and I'm doing only one condition. So not found keys is this one, and that is a list. So it's key for key in the not found keys, and then if the key is not in the dependencies, then we can actually try to find it. So if key not in actual key dependencies, right? Let's run that also. So we get none as an output because we're testing an assignment. But how about now? We do get this list. And then let's see if we can evaluate this. Nope, because I didn't select the first bracket. And now we get something, and apparently, according to this thing, this algorithm, all of the keys are available and they are not dependencies. I don't believe that. So let's check the dependencies for key B, for example. We find nothing. And we know what key B looks like, or where it is. It is right here, and it doesn't have dependencies. That is correct. But how about key I, for example? Or key J. EJ has a dependency which is A, and that looks right. And key H has a dependency called Nothing. Okay, that's also fine. And M returns nothing. So it says that M doesn't have any dependencies. And why do I pass new found keys in here? Those are the keys that we have, and that is contains only C. So M should really have a dependency on C. Oh, but wait a second. I opened door C, so actually that is correct. And I has dependency on G. Okay, so getting the dependencies works. And so we're checking all the keys that we haven't found, and if the key is not in the actual dependencies for the key, what does that mean? No. The actual dependencies are the ones that we actually need to look at. And so out of all of these, okay, I'm not so sure why it doesn't work. It says that we really have like nothing, as if every other key has a dependency on it, but that's not true. Maybe I need to run it again for some reason. So now we see next keys is available, but it counts everything. Not found keys contains everything, and key I has a dependency, and that means that if we're evaluating key I and it has a dependency, then we shouldn't add it to our next keys, but it is added, and that is so confusing. So key I, it is working, but maybe what I'm passing there is not actually a digit like that. Oh, but actually I'm checking I shouldn't check. I should check if there are no dependencies. I shouldn't check if it is a dependency of itself. Of course it's not dependent on itself. So now we get next keys, and these are the ones available. It's all the lower letters plus M, like in the example. So J, K and L are not in this list. That is correct. So let's see, what should we do now? We're going over a loop, and let's iterate maybe till the next step. Like this. And do we get any extra output? No, we don't. Let's run it. Oh yeah, it's breaking every time it's trying another key. I don't want that. I want to break every time. But there's nothing I can use to break on, except for statements. So I need to make something here that does something. Like assignments don't work. Maybe I can do break. Yeah, that's what always works. But I don't like it. It's a bit of a silly workaround. Now we have the following options. We have our position and we have key C. Now this is the path that we took, and I see the same path everywhere. That is kind of correct. And we have the number of steps. Yeah. Now out of these options we can choose different keys to take, and we should take, of course, one of the options here, because there we've already done something. And I want to prioritize the number of keys and then the number of steps that we took. Yeah, let's do that. So we have first number of keys, and I'm going to use today a tuple, again a named tuple for the strategies. So strategy, or maybe it is a state, is a named tuple, and I need to import that. And a named tuple with several parameters, I think. That's how it works. Let me just look it up again. Yeah. Oh, you give it a name and then the parameters. Okay. So we'll call it yeah, maybe I should call it states. I am not so sure how to call a node in your list in a breadth first search. where you're going to try out different options. So basically it's like an option or like a choice. Maybe it's a choice, or maybe it's a step. Maybe it's a step. You called yours state 2. And then what do you call the list of states? You could just call it states or something, or unvisited states. So the first item in the state is the total cost, and the second one is available moves. Ah, it's a move. I like that. Let's call it a move. In the sense of a game, like where you have a move available. Or action. It could also be an action. We have the total cost, and we have the cost. We have the, what was that? Estimate. The remaining cost, and we have target key, and what else? Position, found keys. I tend to add more and more to my states because it's so helpful to have a lot of information, but I'm not sure if it is very efficient memory wise. So that means that this is now going to be a move, and where else do we have a move? Here, but we don't need to use the named tuple here, and here we're going to have a move. You had available moves, and it returned a list of states. And G, you're saying you were looking at in part 2 for a 10 by 10 square instead of the correct size. Oh man, sorry to hear that. It seems to have happened to most people that yeah, they were looking, they were doing the problem in the right way, they were approaching it in the right way, but just with some very small mistakes that kind of makes the strategy completely incorrect. So you've solved it now. I see that you're now on working on part 2 still. You should be finishing pretty soon then. Okay, so what do we see now if we print the named tuples? Maybe it becomes a little bit more readable. Yes. You're taking breakfast instead. A very wise decision. Maybe I should also do that. I think I'll go on for another 20 minutes or so and then eat something as well. Right. Where was I going? I was checking all of my moves that I have available. And now we should sort it. So I want to look at the number of keys and keep that as a sorting parameter. So let's have priority as the first one. That's what we're going to sort by. And so I'm adding it also here. And what else? When we add it, we need to make a new priority. And the new priority will be how many keys are left. And that is the length of the number of keys that we have minus the number of found keys, new found keys. And also I want to keep in that priority something else. I want to keep in it the number of steps that we've taken. So that is the new total cost. Well, basically the cost. Yeah. So the less the less keys we have left, the better, and the less total cost we have, also the better. And now I want to use a priority queue instead of just a simple list. And I'm missing something here. For the first one, I have my keys remaining is the length of keys, and the total cost so far is 0. And I'm putting all of my sorting parameters in the first tuple. I could have also just done it like as the first, second, and third element of the outer tuple. But I don't want to refactor too much when I change the order of the priority element. Now we can run it, and we have a lot of output now. It is a bit too big. I think I'm going to rename remaining cost to something a bit more short. Maybe it should be called an estimate or something. I'm not even using it right now. Or our cost. Yeah, it's a bit ugly, but I want to be able to see the whole tuple on the screen. Right, now it fits nicely on the screen, still on as long as we have short paths, of course. And we see now that in our path we don't have the origin. So maybe that is correct, maybe it's because we don't actually need to count that one as a step. I guess that is true. And so we have our priorities here, 16 keys left for all of them, because we haven't tried anything yet. But after we get the key C, now our costs are going to be very different, because our estimate for going to that other key is going to be very different. So I'm going to make a little bit more space here. For getting key E, for example, we're going to be at 6-1, position 6-1, and we're going to have a path here, and our cost is going to be 6 because that's how much we've traveled so far. But the estimated cost to get to target E, well, we could technically calculate that because we already know it. We have a function to calculate that, and there's something else about this that I'm never so sure whether you're going to, when you're expanding your nodes, are you going to calculate the cost up till that node there, or are you going to evaluate the node in the next iteration and then calculating how much cost it was? That I don't know. So here in our total cost estimate, we still have nothing, but that is not really how I want it. I'm in the wrong section here. So the new cost is going to be defined as the length. Okay. Yeah, so that means that all of our options are going to have the same kind of priority, and I don't like that. I want to be selective a little bit earlier. So maybe we can calculate the next key cost, which is just the cost of going to that key directly. And we know it's available because there's nothing on the way to that key. Get path from the keys position, that's the next key. So we're starting at the current key position, but we're gonna go to the next key, and to know the costs of that, we can... No, I guess we cannot calculate it yet, because in the starting state, we also don't calculate the distances to all of the keys. That's something that we do later. So I will not do it here, but that means that we're going to evaluate a lot of things. Well, we're going to start with the one that has already some keys found, so that is positive, but it is pretty much depth first search at this point, because we're starting with key C and we're just going to explore right away only for key C until we're done, and then we're going to probably optimize the path for key C, but we are not going to try key B very quickly. So maybe this strategy is not going to work very well. And I did kind of want to do a breadth first search, so that means that I have to try out different keys first. Let's say I have to try out all of the keys for at the root, at the start, and then look at the costs, and then continue with the least costs at that point. So what does that mean? I should not sort this list, but I should sort it. So as long as we still have 16 on the queue, we should actually go over those. But when everything is equal, then we're going to take the other ones. So maybe that means that we're actually going to explore the path where we have the least keys all the time. And so that means we're actually sorting descending for the number of keys and ascending for the number of steps. Maybe I can use that as a priority. So the priority is based on how many keys we found, so that with 0 keys found, we're going to try that one first. So it's kind of breadth first search on the keys and depth first search on the steps. A star on the steps, maybe. Or a Dijkstra's algorithm on the steps. Okay, we have not a priority queue yet. I'm just going to rerun the code to see if the options look kind of right. So 16 keys left. Oh, right. When I start, I have to also calculate the start correctly. And in the start, we have the number of keys found, which is going to be 0. So it's all 0, and then we'll run it. This is all irrelevant. New priority is the number of keys that we have. No, number of keys that we found, right? So now we're going to continue with these ones on the top. And then after we do that, we're going to continue with having 1 key. Okay? And now I need to have a priority queue. So I'm going to use heap push, and we're going to put it in the list of strategies, which by now I definitely should rename to moves. And here, instead of just doing, I was doing a heap pop actually, but I'm not sure if the popping really works well. Let's run it and see. So we're getting C because that is the first one on the list. Then now the next one is getting B. Okay, so we do that a bunch of times until we have no more options left with 0. And I do see here that the list is not exactly sorted, but maybe we do still pop always the one with priority 0, 0. So we took G, that is correct, and then later we should get H. And that's what we did. Out of this list we took H, okay. And then we're going to try other options. And now we're getting A and we have B, and we're trying A. Why exactly? I don't see any costs written here, but we do have a path already. So do we not calculate any costs? The cost should be the new cost, right? And new cost is the length of the key. And let's look in our list. Yes, we have cost here. It is being incremented. It looks correct, but just the priority doesn't look right. So because we should use the new cost. And let's run it again. So now we're going on with B, and we see some costs showing up here. And so we are still trying all those ones where we have a lot of first keys to try. And at this point it's becoming a little bit too much to keep on one screen, so I'll take first 10 options. So I'm iterating a bunch of times until the best option is the next key. And so the best option so far seems to take A and then, no, first B and then A. And we're trying now all the second keys. Which one is the best option? And then when we have done that, of course we have a lot more combinations for the second key after trying the first key, so maybe breadth first search is not really the right way to go. We do have a cost estimator, but I would like to combine the cost estimation. I would like to combine the number of steps we have taken and the number of keys that we have found. Maybe we can use an average, but it's not a really good cost. Are we trying to optimize the number of steps per key? I guess we are. I guess that's what we're trying to optimize in the end. The number of keys is constant, so in the end, if you can optimize the number of steps per key and the keys is constant, you're optimizing the number of steps. And maybe that is something we can do to sort our priority queue instead. Well, gee, you solved it. I hope you had a nice breakfast and a good time to get the second part done. Yeah, that's what I'm going to do. I'm not sure if it's really correct. So now you're taking breakfast. Okay, enjoy it. The new priority is the cost per key so far. And it would be cool if we could actually estimate the total cost per key. I don't know how we can do that yet. But that's what we can do. We can do it this way for now. So we'll start with estimated cost of 1 step per key. That is very optimistic. And we should be optimistic if we want to use A star. And so after this, we have found 6 steps per key on average. And we're going to try a lot of things. Let's print the strategy that we're actually going to use. Let's just print it like this. So we're getting E, and then I want to print the entire strategy, just like that. Oh, we don't have a strategy right now, because I need to make it like this and then unpack it. Now we can print the entire strategy. And maybe I do want to keep a list of the keys that we found. Maybe I'll put it first. And then plus will be the one that we're going to add. And then we have the strategy after that. So we have the found keys like this. I hope that's going to look a little bit nicer. Almost. Just need to use the right formatting function. Reformatting code. And we still didn't format it correctly, or we didn't run our code again. So for those who just came in, I'm working on day 18, as you might be able to figure out. I haven't finished it yet, and I'm trying out to see if it helps to calculate the average number of steps per key and try to optimize that, and then to always go for the option with the lowest value. We have the number of found keys here, which is 0, and the next key is going to be C, and I'm going to print it like this. Okay, that is a bit more clear perhaps. Okay, so we're gonna take key C, and we have no keys left. We have no keys found yet. So now, after that, we're going to continue with A after finding B, because it has 4 steps per key. And now we're finding that actually that is quite a good one. The number of steps are decreasing little by little. And at some point, I'm not sure why we didn't continue right away with the other options that were still regarded as 1 per key on average. Well, this is a very long path already, so Maybe that's why. Maybe it is just a good option. Okay. Well, it seems that we're finding new keys very quickly. So this algorithm is definitely more quick than what we had before. And we need to decide also when we're going to break. And hopefully when we find all the keys, then we are done. So let's check if remaining keys. So we have the not found keys here. And if we don't have any keys that aren't found, then we're gonna break. And we'll say that we're done. And we are done, and our costs. You know what? Actually, let's check that. Yeah, let's check that here. That is fine. And we're breaking. Okay, so let's run all of it. And I have a breakpoint here that I do need to kind of press enter for. At every loop, and I'm not sure why I don't see anything else. So let's run it. Trying a lot of things. Now we are done. And when we are done, it means that we have found all of the keys. So I think the last step was probably this one. But it might... Oh yeah, this might not be the one that was actually working. Hold on a second. Why is the last thing we see in our output not the solution? Or maybe it is the solution. It means just finding M after finding all of these, with an average number of keys, steps per key of 1.1. And the cost is 17. So we have a total cost. Let's say what the total cost was. Like this. But that should be the new cost. Are we increasing it? Here, new cost. That is actually the length of the path plus 1, in fact. So I think there's something a little bit wrong about it. Maybe... Yeah, I think it's the length of the path plus 1. Because we start with an empty path and the cost is 0. Oh, okay, so it can be 0. But when we found the key, that means we did move one step, right? Or we did actually move quite a bit. So the new cost is not the total cost, it's the incremental cost. And that means we're actually not calculating the total cost. So we need to optimize the total cost. And that is new total cost. That is the cost so far plus wait a second, this new cost is really not very correct. The new cost is the length of the path plus the length of the key path, right? And then when we're calculating the cost for the other keys, yeah, we'll just use new cost, that's fine. Okay, maybe like this. So after we found the key, the priority is based on this new cost, and we can use this. Okay, let's see. We can always test it on some smaller and simpler examples. So it runs quite a lot, and we get a total cost of 42. That is a bit of a magic number, and let's see if that was actually correct for that example. So the example I'm running is the one with equidistant keys, and here it says that the shortest path are 136 steps, and one is, that means that there are multiple ways to do it, and what we are doing is going to be BAC and D. Okay. Well, that's just one way to do it, right? Maybe there are multiple ways to solve it. I want to kind of keep it in a list of solutions and not break when we're done, so that we see that we actually have the smallest solution. So we're gonna try all solutions. Solutions.append. Let's append to it the found keys, or the new found keys, and the new cost. Only that. Or maybe the other way around, so that we can sort it in the end. So we'll sort it, and then we'll break. Maybe we can do a breakpoint like this and run it in debug mode. So I don't know, this might run forever. There might be really too many options. Maybe I should do a breakpoint at some point, like here, and look at our solutions. We do have already 224 solutions, and some of them have 42 as a path. Okay, so the costs are very low, and what it means to me is that I'm not counting the costs correctly. So I should end up having 136 steps. So our basic cost is, this is a loop we don't need. We are starting, where are we starting? We populate our strategies with something, right? Our moves are populated here with all of the keys that don't have dependencies. And we're saying that starting at position 0, 0, and we have no costs so far, then we can explore some keys. So we take some key from the heap, or some strategy from the heap, and we have a cost that is 0. Then we find the path, the shortest path to the key, and that has a certain length. And I want to break right there to see if the path length is correct. So we have a path that starts at 8, 4, and let's look at the map. And we're starting at 0, 1, 2, 3, 4, 5, 6, 7, 8, and we're 4 from the top. So the first element is correct, and we're going all the way till 6, 1. 6, 1 is 2 off the left of our starting point, and 1 is 1 above the top. So we're going to see position C, and that is 1, 2, 3, 4, 5 steps actually. And our path, our key path, has 6, I think. Yes, it does. So new cost is the key path minus 1. And of course including the length of the path that we had so far, right? Now let's say that we continue with the first one as well. Are we going to continue with the first one? No, we're not. I want to see what happens if we then continue to get anything else after C. So let's run it until we see that we have key C in our pocket, or key B. That doesn't matter actually. Well, you know what, I'm gonna go until I see C there. That's not gonna happen because we're very aggressively going for our best option so far. Okay, that means I'll try it with key B, this example. So we found C, and here we found B, and then after the first few items we're gonna try with B, and then we're gonna go to A. So when we went to B, we went from 8-4 until 6-3, that is this one here, and it took us 1, 2, 3, 4 steps, but it's 4 positions, so excluding the first one, that's 3 steps, and it says that our cost is 7. Now that doesn't look entirely correct. So why do we get cost 7? let's see. So we have our move that we're making, and this parameter is the cost, which is new cost, okay? And new cost consists of the length of the key path at the point where we were so far. So that is, we reached key B with this path, and it's not so clear why we're calculating the cost of 7. Oh, I'm doing key path twice instead of path. Okay, so that is what I did wrong. So let's do it like that and run it again. So, getting all the first keys, and then we will continue with key B after getting key A, and key A, no, we're continuing with A after getting B. B has 4 steps, which means a cost of 3. It should still be a cost of 3. Because our first path should be empty. We can have a look at the path that we have. It's this one. Right, okay. Actually, the new cost... Wait, the cost says 4 here. And we are using new cost. So I think I need to actually stop here to stop at this line and see why I'm adding items to the list, to the moves list, that have an incorrect new cost. It looks like I'm just taking the length or something, but I am subtracting 1 even. So let's do again a loop until we are trying key B, and it should be one of the early ones. This I don't want to do every time. So here's B. We find that the key path was 4 steps. Our current path... Oh, our current path is not empty. That is not correct. So we are starting with a path with the player in it, and I've assumed that we didn't. So now should go a little bit better. And that means that we probably don't need to subtract anything, but let's see. Maybe we do. So we are now doing B, and we've calculated the new cost, which is 3. Maybe I should just call that key cost or something, because it's kind of the cost of the additional cost of getting that key. Then let's just loop again until we have found B, and we'll continue with A. Then our total cost, our cost so far is 3, and total cost includes the rest of the puzzle, which we cannot calculate. So for now I don't have it. Right, so that looks fine now, and then we're going to try to iterate. We have a new path to go from B to A, which starts at 6-3, which is here I think. 0, 1, 2, 3, so we're starting at B, and we're going to A by first going right, 1 more right, 1 down, 1 more down, and then 1 left, and then another 1 left. So 6-3 is included in the key path, which I don't want. So when we actually add it to the total path for any key, then we're not going to add that one. So it's going to be key path excluding position 6-3. Let's try it. 6-3 is not included, and with this one it is included, so that works. Now we can basically keep running it and see if we get a bit better values, because we should get 136 steps. So we break and see what we have so far. Do we have costs that are high or that are low? We have no solutions yet, So maybe okay, I'm breaking actually when we have a solution, so we can just keep running it. That does take quite a bit of time. And it would be cool if we could see what it's actually trying to do. Maybe we can. Yeah, we can, because we have a function for that. And it's called print maze. And our current position is... I have it here as position, I'm not extracting it yet. And we need the x and the y, so it's position 0 and position y. And then the current path we're on. Maybe the new path. Let's just extract it. New path is like this. It's the same for all the keys, so we don't have to recalculate it. So like this. And we're going to print it, and let's see what we get. Also, I want to clear the screen. Why are we doing that? We're not clearing the screen. That is called os.system and then clear. And now we can run it and get some output. Triple index out of range. The position has a 0 as a 1. That. Okay, so now we can see what it's doing. It's doing a lot, of course. So maybe we can go one by one. Let's see. So it's trying really... It looks like it's trying breadth first search. Not exactly. I'm glad you like it. So I guess because in this case all of the options are roughly the same, then it doesn't really matter, and that's why it's going to explore very broadly also. I'm not sure if it's gonna work in the end, but I must say my realization of optimizing the number of steps per key was really a nice one. Because that means that you can actually get a feeling of how well you're doing with your strategy even before you reach the end. Okay, well, it is running and running. Let's run it until we have a solution. And maybe right now I don't want to print everything anymore, but at least I want to print the maze because it looks cool. So we're gonna run it and break at some point. This goes a lot faster. Looks nice. And yeah, we're going to evaluate a lot of positions, of course. And what's nice now is that I don't have to think about walking back over paths that we've walked before and considering whether or not we are doing that with a different set of keys or not, because we're going straight to the keys. So the steps are much more quick. But there are still a lot of combinations, a lot of different ways to solve it. Maybe what we can do is try to solve it first on example 1 and see how long that takes. Because if that takes long, then definitely this is not going to be working on our full puzzle. So that is already done finding a solution, and it's breaking also. Example 2. Let's just run it. So that one was done pretty quickly also. And then it is still running, trying to find another solution, I think. Or where is it breaking? No, I can do a breakpoint right here. Am I breaking anywhere else? Oh yeah, at the end. Okay. So actually, let's do continue searching for more, maybe like this, and then it will just continue if we hit enter. So we run it, and now we get continue searching for more, and we can do yes, but it's actually done. Here we can do sys.exit to actually quit completely. Ah, hold on a second. So we have a breakpoint, and what can we do here? Oh, we can do something like this. Okay, interesting. I didn't know that interactive breakpoints work like this. You can do question mark and then do something like continue, and then it actually does continue, and it does find other alternatives. And I'm not sure if the alternative that we found was actually the best one. It says 144 for this example, and the shortest path is 132. So that means we should actually continue. We should find one that is a little bit faster. Here we have 132. So how do we make sure that we are going to have the quickest path first? And I think the estimate for that is that we need to think about how many keys we have left and how many steps on average it's going to take us to find all of those keys. And that's something you cannot directly calculate, I think. So let's say, well, we can do something. We can say, well, if we have a lot of keys, we still need this key, and we're right now here, then the average number of steps per key that we're going to have is at least the shortest path to the nearest key. Let's say, no, it's going to be at least taking the distance to the furthest key and then dividing that by the number of keys, which is 2. Right? That's at least how many steps per key we're gonna have left. If I could do that, then I have to do shortest path to every key that is remaining and calculate that. I'm not sure I want to do that, but it might be super slow on the real input. So let's try it on the real input. And for that I need to change my console font to something very tiny. And I'll put it in a new window like this, and we can run it. And I see that it's very slow. It's probably gathering some doors and stuff. Okay, now it's doing something, and it's really doing cool things. It's so much faster than my first try. And still, my Python is still slow. This used to be updated like in a flash rather than so slowly like this. And yeah, I don't know why. Something is not going right on my machine right now. So let's break for a second. Oh, I can't break at the moment. I'm trying to see how many keys it found, and so far it's doing a strategy with 2 keys only. That's not very good. And I know that we are starting with trying out all of the keys, and that will have a very low number of steps per key, because I haven't actually recalculated that. I just put it on 0 or something, or 1. And now we have how many keys? 3. We're doing now 4 keys. Yeah, this is taking a long time. And yeah, I'm wondering if it's the printing that takes so much time or something else. Maybe, let me check my activity monitor again and see if Python is still running, even though I haven't started anything anymore. My activity monitor says that Chrome is running hard and OBS is running hard, and some dashboards. And that's it, and Python is not doing anything. So, okay, and that's just how it is. And I don't want to print this maze every time. Maybe I want to print it only... Yeah, for this I had a nice, very nice interactive shell where I could give a command and say if I want to render it when I find a new key or something, or under some other conditions. And right now I don't have that. But this is going to be a bit too slow. Maybe I won't print the maze, but I will print the list of paths and those sort of things. So let's run it again and see. Look at the output. So the first section is also quite slow, which is the part where it gets all of the dependencies. And also, what else is it doing? Nothing actually, it's just going over all of the keys and then getting the shortest path for each key. Calculating path to each key. Maybe I'll add something else. Checking key dependencies. Calculating path for key. Like this. That is the key. Checking key dependencies. Well, that's just a simple loop. That's not going to take a long time. It's probably just going to be this get shortest path function that is not super fast. It is not super fast because it's a breadth first search and not a star. Maybe if I would change that into a star, it would start to be a lot faster actually. I will commit this and then improve from there. So, day 18, part 1, work in progress. Yeah, it really takes about like several seconds actually. Come on, let me click this button. Okay, it takes several seconds per step, and we have found 5 keys so far with this particular move, and sometimes it iterates quite quickly actually, and sometimes not. So you see now that it's jumping relatively alright. I think if we can improve the get shortest path function, it is definitely going to be a whole lot faster. So our paths are going to have, yeah, it starts with a single position, a list of a single position, and instead of pop we're going to use, hold on a second. Breadth first search is fine to use in this problem you heard. Key to key path distances was one of the things you had memorized and cached. Well, that is a good point, because you're actually not going from any random location to any random location. You're always going from a key to another key. That is true. I can actually memorize that. Well, okay, that was a very good tip. You mentioned it before. So rather than recalculating it in a more efficient way every single time, we can also just store it. Shortest path cache. That has basically 2 keys as an input and then a path. So let's have it like this. So the shortest path from 0 to 0 I'm just doing it as an example. So from 0, 0 to 0, 0, the shortest path is empty. Like this. Or maybe I want to keep it including the start and end point. Like this. And you stored Also the paths, yeah. Okay, so that's what I'm about to do now also. So after we find a path, we're not just returning it, we're saving it in the shortest paths cache using the start and the goal. Start and goal, and then saving it. And then when we start, we can check it. So if the tuple of the start and the goal is in the shortest paths cache, then we're returning that one with the start and goal. That is easy, right? And the length of it is the most important part, not the actual path itself. Well, in my case, I am calculating the length I'm calculating the cost using the path. So in my case, it would help to do it that way. You might be right that I don't need to do that, but I'll keep it this way for now. Oh, let's rerun it and see if it is faster. Oh, I have no idea actually if it's going to be faster, because I didn't look at how many keys we found just a moment ago. So there we have all the distances. And, well, is it faster? I don't know. I guess it's going to speed up as we go, because then those paths have been found. The path can also be useful for caching the other keys on that path as an optional optimization. Yeah, so that's something I haven't actually considered yet. If I'm going to a certain key, that means that I will also have another key right away. So right now, if you're kind of accidentally passing another key, you're not picking it up. So, in other words, I'm only picking up the keys, that I intend to pick up. That's another optimization I should do in general. So we have now found already 6-7 keys or so, and it's not really going super deeply into the maze, I think. And instead of the whole path, I don't want to print the whole path, I want to print only the path length. Maybe I can do that by replacing this path with none or something. Otherwise I'm going to have to unpack the whole thing. I guess that's what I'll do then. Maybe can I make a tuple, a copy of a tuple? How does that work? Strategy.clone? No. Clone? There is a function called clone? No, there isn't. Copy? No. Well, maybe tuples are immutable and I can just copy it. Maybe I can just do x is strategy. Well, without using the variable x, of course. Maybe like this, and then say strategy.path is none. And then use this strategy here, so that I don't get so much output. But I don't want to change the actual path on strategy. Although we just popped it, so we're actually throwing it away anyway. Or maybe it doesn't matter. Oh, I can't set an attribute on a named tuple. Ah, you cannot name... Ah, yeah, that's right. You cannot actually change tuples in Python, which is not a coincidence. Python copy tuple with different attribute. Oh, maybe, let's see. New tuple. Oh, with a dictionary. Oh, that's cool. So I can do it like this. New tuple. Or this is a piece of code? No. It's really called new tuple. But that function is really built in. So we use the strategy as keyword arguments, and then we'll just change path with none. No, that doesn't exist. maybe, how is it called? It's called move, right? Oops. Okay, so we're making a move. Ah, yeah. Okay. Nice new little trick. Calculating those first key paths is kind of boring, I must say. It should be a lot faster with A*. And if I'm calculating an entire path and I couldn't cache it, I'm going to print it. Oh, and I cannot do it this way, because it's a tuple and not a dictionary. And then I have to do asdict, as is already explained. Okay, so I'm going to make it A*, and I'm also going to show when it is recalculating the path. So printing, calculating shortest path from one to another, start and goal, and let's run it in the background while I continue making A*, because I think that it's probably still doing too much of this. And A* just means that I'm estimating a distance. Now I'm not so sure if I want to do A*. Well, we have paths and we have a start position, and we're going to calculate the distance, which is the Manhattan distance between start and goal. That is our estimate, or kind of overly optimistic estimate. And now it says it got multiple arguments for path. Really? So this whole trick is really not so good. Maybe as a dictionary and then without the key or something. Maybe we can do a comprehension. Oh, so much trouble for such a simple idea. So asdict.items, and then we'll take the key and the value from it for kv in, and then like that. Kv, so a k as a key and a v as a value, and that might be required to be some kind of tuple. No? Okay, I'm just going to do it in another way. So I'm going to print every section like this, and after every comma I want to have an equal sign. And I'm going to print only the path length and not everything. So that is going to be with a lot of variables. This. Now I hope that they are all going to be converted into nice strings and the length of the path. And then we can run it. Yeah, it's calculating all those paths. Not enough arguments for format string. Oh, I have to do it like this. Now again, I was waiting for the shortest path, so I'm going to optimize it. We have the Manhattan distance, right? And when we are popping it, we're going to say that we need we have to have the total cost so far also, and the total cost so far is going to be 0, and we have a sum of this one. Hold on. So remaining cost, or steps left, is this, and this is the total estimate. And this is the, oh man, this is getting a bit messy. I wanted to do it like this. This is the steps so far, and then the last one is going to be steps left. That's an estimate. That is calculated using steps left. And then we need another closing bracket. Let's see. So as we are popping, we have a total estimate, and we have steps, and we have steps left, and we have the path, the actual path, which I forgot to put here. So the actual path is nothing at first, and then why is this not working? That is actually working with just a little warning. Okay, and then we are going to use a priority queue on the path. So that just means that we're going to use heap pop instead of pop. That's all you need to do to make a star. And we have heap push also. And onto paths we're going to put not only the new path, but all of these parameters. So that is the new total estimate. That is the steps we've done so far, plus the steps that we estimate to be left, which is actually the Manhattan distance from our position where we tried to go. So that is the new position, plus then the goal. And okay, what else? This should be a tuple actually. Total estimates, steps so far. Wait a second, I should do it like this. So we're pushing onto paths. No, it should be like this. The total, the steps so far, and add to that the path length to that position. No, not entirely sure. Actually, it's just +1. So we're taking another step. And I'm really going to have to write this in a structured way because I'm getting confused. So, total estimate. Steps so far, steps left, and the path. That's all we need. Total estimate is the more difficult one. The new path is the easy one. That is just available to us. Steps left is the Manhattan distance from the new position till the goal, and we should subtract, no, we should not subtract one of those. And the steps we've taken so far is the number of steps +1, and the total estimate is the number of steps so far plus the remaining steps. So let's calculate that. And steps is steps +1, and steps left, and so here will be the new steps plus the new steps left. Here will be the new steps, and here will be the new steps left. Wow, it's not that hard. It took a long time to write that correctly, but we now have a heap based on the total estimate. So that means that this first section should go a lot faster now. It goes so fast, in fact, that it's crashing. So maybe path doesn't work exactly. We're taking the last position in the path, and here it seems like I was intending to put the start already on the paths. Did I do that before? Yes, I did. Okay, then let's go. I'm not sure if it's a lot faster. It doesn't seem to be really faster. But maybe we should also check if it does calculate it correctly, but we'll see. So here now we're printing and something else was not right. We have priority, total cost, cost, remaining cost, target, key, position, and found keys. And then path, which also needs a parameter. Yeah, I'm a bit surprised that the shortest path still takes such an amount of time. Maybe we can print it. That is cool. We can actually print it. So let's print the maze with XY being 0, 0, or actually just player 0 and player 1, and then the key path. Shortest path, that's how we called it. And let's rerun it. Now we should actually see the paths to all of the keys being rendered. Okay. Well, those look like actual paths, and I guess they are correct. But there's no other way to reach J in a faster way than what we just did. We cannot go in the left quadrant, so I guess that is the only way, in fact. Still rendering all of those paths. Now it did key Z. Oh, it's not doing it in order. Now we are actually starting to calculate. We're still calculating a lot of different options. We're not using our... Now we're starting to use our cache. So whenever you see it kind of go very fast, that means that we are able to use our caching. I'm going to make the screen a little bit bigger. Oh, Emily, you finished. Nice. And my stream is extremely buggy right now because of Python running at full speed. Maybe that is something I need to think about, how I can run my Python code with a little bit less priority. Yeah, the paths have no loops. That's something I realized also. Yeah, it's not super clear when you just look at it, but if you kind of look carefully, you see that there's no loops. And the center actually caused me a lot of problems because yeah, because it tried like a lot of different combinations for crossing the center. Very annoying. Because every combination of steps in the center is almost equivalent. So the number of found keys is increasing. Oh, you missed that center and went wrong there in your first implementation. So in what way did it miss the center actually? Did it not take the shortest route or something? By the way, I do still have a problem with this implementation, and that is that it doesn't find the shortest path right away. It just finds paths, and then after that we still have to try other paths. You brought your computer to a crawl multiple times with 20 gigabytes of badly structured Dijkstra nodes. So, okay, I am also using Dijkstra's algorithm basically, because I don't have a good cost estimator. Oh wait, I do. I have the number of steps per key. That is my estimate that I'm using right now. It seems to kind of go faster. And some of those shortest paths are very slow. Not so sure why. I mean, it's all walls and you can't choose a lot of directions, right? Let's see if I can actually configure PyCharm in such a way that it runs Python code with not the highest priority. That would help. Yeah. Like nice, basically I want it to be nice. If you are familiar with Unix terms for lower priorities processes. PyCharm run Python nice. Although I'm not sure if nice exists on a Mac. CPU priority or something like that. Yeah, how to limit CPU usage for PyCharm. Somehow in your implementation the four corners of that had 3x3 had different path lengths because you skipped the center square. Oh. Ah, because it can be the one you've visited already and that's where you start or something? Ah. CPU profiling. This is not it. Maybe I can just say Python run with Python CPU limit. Restricting CPU process usage. Well, of course I can open my activity monitor and try to change something there, but I don't want to do it every time I run something. So here I see some kind of example. Wow. Signal. How to limit CPU. Okay. And we're going to set a limit. Okay. Interesting. And we're getting a hard limit and a soft limit. Okay. And does it work for the Python code itself, or for Python in general, or for this particular process? Maybe I can just copy and paste this and see if it works. So, well, actually we are still running and it is taking a long time. We have found a whole bunch of keys, but not so clear how many because it's jumping around all the time. What can we do? I'm not able to resize this window anymore. That is not a good sign. Oh, I think I had a preference window open. So this is what you can see now. We have about 8 keys in our pocket, and it can be that key number 9 is so far away that our priority is going to change drastically. So basically, instead of trying to find key number 9, it's going to try to keep optimizing the keys it already has. That sounds like a psychological problem that I'm familiar with, where you know that you're working on a project and you need to make that next step, and it's quite a big step, and you feel kind of like procrastinating. So instead of going to that next step, you're gold plating what you've already done. And that is what my algorithm is doing right now. I'm kind of happy with how fast it's running, but it's definitely not fast enough. So it doesn't want to try the next key because it would mean that it's going to bring down the average number of... It's going to raise the number of steps per key. Well, is that a reasonable... Is that a good reason? Is that a good line of thought? That, well, what if every key after the first 8 is going to be very far away? That is possible too, right? Then you really have to get going and not try to optimize it. And it might be possible that you've already found the fastest solution also. So it is kind of also showing a lack of good estimation, because all of those 8 keys that we found so far, they should have included also the estimate of getting key 9 in it. So that means that actually trying to get key 9 would not increase the number of steps per key that much. Just thinking out loud here, thinking how I can avoid this problem. You see now it's starting again with a very small set of keys. Really trying all the way from the start, maybe trying a few keys that are far away, trying to avoid hitting that kind of roadblock for key number 9. Well, it could be a good strategy, but I feel like we're not making enough progress. So what is a good estimation function to go to the next key? Well, basically you can do that. You just need to calculate. No, you can calculate to the next key, but not till the very end. Yeah, and the funny thing is, if you use breadth first search, you can end up the moment you find a path. That is true. And that is true indeed, but I am just feeling here that going breadth first search is not an option, but maybe it is an option. Maybe I just need to try everything. But I am kind of trying everything. I'm just trying everything in a different order. So I'm not sure if I would save any time. Well, I would save time because I am... On one hand, I would not try out solutions that are going to be further. Let's see. No, wait. Do you mean a breadth first search on the steps or on the keys? Because breadth first search normally means that you take into account the depth of the tree you're in. So if you're going to find a solution at level 3, you're going to find it with only 3 steps, because you're trying out level 1, then 2, and then 3. But if your steps in the levels have costs and they are not the same, then you don't know for sure that your shortest number of steps is also the lowest cost. And I am jumping from key to key, and I'm not walking step by step in the maze. So if I was able to get, well, basically any solution in my search is going to be 26 steps. So every solution is 26 steps. And but I think for me, breadth first search, just by choosing the keys, is not going to work, because it's a permutation problem and not a pathfinding problem, basically. So I'm doing a star on the keys, kind of. Yeah. And that means that we have a kind of cost estimation. And so my cost estimation is, I'm estimating what is the total number of steps, the average number of steps per key. And I have no idea if that is a good metric. It seems to work for small puzzles, but what other metric could I use? In the end, I want to know the total number of steps. And if I would just use the total number of steps like Dijkstra's algorithm, and not, well, I mean the total of steps so far, then I'm always going to explore the shortest paths. I'm always going to explore the situations where I had only 1 key or 2 keys, and then just keep trying permutations of those over and over. But that doesn't work, so I have to kind of keep into account also the remaining keys. So maybe I can think now of some way to estimate total number of steps. And what I can do for that is to basically divide the number of steps. Yeah, I was showing it earlier already, and that is a strategy that I can try. So we have our grid and we are at a certain position, like here, and then we're taking the furthest key, or we could actually take the key that's furthest away. We have already calculated everything, so that should be fine. So the key that's furthest away, we take that and divide it by the number of keys left. So that means the number of keys by the number of steps. No, it's the other way around. It's the number of steps divided by the number of keys. That should be the average for the remaining part. So basically we can have our current number of steps plus our estimated number of steps to the furthest key, divide that by 26. So basically we don't need to divide that at all, because it's a constant. That could be our estimation function. But that also means that yeah, we're going to try to walk to the furthest key always. And that also doesn't help. Maybe we should not divide by 26, but by the number of keys that we have taken. Does that make sense? It means if you can decrease your number of steps per key by taking another key that's nearby, then you're doing a good job. But if you take a key that's far away, it's not gonna help. So yeah, I'm not so sure about a good estimation function still. And now it's just running and running, and path lengths are increasing. And even if we find a solution, we're not sure yet that we're going to get the shortest solution. So I'm very unhappy about this. Well, I think it's just a matter of that I'm braking in the wrong way. Or maybe, well, if we have a position, a goal, if we reach the goal, and that means that we're trying out a path with a certain priority that is really the lowest. Yeah, but without an estimation function, we cannot actually guarantee that we have the shortest path. So we do need to estimate how many steps we're going to take for all of the remaining keys. And I would say that it's going to be at least 1 step per key. So that is the best estimate I can give. I don't know anything else. It's at least 1 step per key, right? So let's calculate that. So it's at least the number of steps to the furthest key, actually. Plus 1 step for every other key. That means that all the keys would be far away and all lined up. I think that's a nice one. So it will look like this. So we have a bunch of keys left, like here, here, a bit bigger, like here, here, and here, and here. So the number of steps we have to take at least is the shortest path to the furthest key, this one. So that might be like this, for example. And then at least 1 step to go to each other key. So let's calculate this as 1 step, and this as 1 step, and this one. Of course, that's not true. The real paths are going to be much longer, but we are not sure which order we are going to take. So we'll just keep it simple and do it like that. So then priority will consist of only the total, the cost so far, plus an estimation of the cost. And the cost estimate, well, hold on. So that means that priority, okay, actually we're not reading from the priority, we're just sorting it by priority only, so it doesn't matter if we change from a tuple to something else. And the cost estimate, that is something that I'm going to get from my state, actually. So that is the remaining cost. And first, in the first state, when we're starting out, we are now saying that the estimated total cost is 1, and that I don't know. Start cost estimate, and we are going to take the furthest key. Furthest key, that is out of all of the keys that we have, we want to sort it by the one with the longest path. So we are going to return the name of the key and the path. No, we are returning the name of the key for every key path combination in our key paths and the items of that. And actually the max by, hold on a second, we need the path for our max calculation. So we are going to return every item in there. So basically we just take key path items, that's it. And our maximization function is going to take for every item, that's a lambda, going to look at the length of the path, which is the second element in the item tuple. So this is the furthest key if only we take the first element. And furthest key distance is the length. Oh, okay, actually we can just do it like this. So we have the furthest key distance like this, and we can use that as a cost estimate. And the start cost estimate is furthest key distance plus the number of keys. Now I have the beach ball of death, and I do recover from this beach ball crash, fortunately, and so 1 step per key left. But that's like -1 with at least 0. I don't want to go negative here. Like this? Okay. That's our starting cost estimate. And that is not a tuple anymore, it's just a variable, a value. And I think this is a handy piece of code. So I'm going to make that into a function. At furthest key distance. Or actually, maybe what we need to do is estimate remaining cost. And for that we need to know the keys that are left. Remaining keys. And what else? I think that's it. So we can just return the cost estimate. Return cost estimate. And we'll use the remaining keys instead of all keys. So we have key paths, and we only need to consider the key paths. Oh, but hold on a second. We cannot just use key paths because that only considers paths from the start till our key and not any sort of path. So we need to have a position also. And so then we're going to calculate it a little bit differently. So we have remaining keys, and for each of them we're going to return the length of the shortest path to that key from our current position. Item will be actually the key, because now we don't have tuples anymore, we just have a list of keys. And get shortest path from the position to that key. Then we have the furthest key and furthest key distance, right? Hold on a second. Would be cool if we could actually return the key and the distance instead of just the best key. Although if we calculate it a second time, it will be cached. We're not supposed to know that. As we're not supposed to know that, I'm going to make a new distance matrix. So for every key in the remaining keys, we're going to return the key and shortest path to that key. And we don't need the actual path, but just the length. So we can do that by doing just len. Am I doing it right now? Yeah. Okay, so furthest key and furthest key distance. No, not yet. We need to, these are the key distances. Or actually the key paths. Remaining key paths. And then the furthest one, we can just do a max. We can do a max over that. If we would reverse it, we can do a max directly even. Because max will compare the tuples, and the first element in the tuple will be compared first and then the second. So then we get the distance and the key. And we don't really need the key. That's true, we don't really need the key anyway, so why don't we just... why didn't we just map... Okay, why didn't we just do it like this? Just getting the length of the furthest key. The max length of the furthest key. Furthest key distance, like this. Okay, now I think I got it. So that is our remaining cost function. And we do need to fix up some things here. So we have the braces left. And here we need a length. Yeah, just adding symbols everywhere for no reason. And we don't need braces. Actually, we can do it. We can just pass an iterator into length, I think. Not entirely sure. Let's try it. Do we have any Python console open? Yes, it is underneath our run. So the length of our range, 0 to 10. Yeah, that works. Okay. Getting the shortest path from the position to the key. And it shadows the name from the outer scope, that is fine. So the estimate of the remaining cost is going to be based on our position, which is player, and remaining keys is all of the keys. These values, that's what we use. Well, okay, let's start and see what we actually get as a starting cost. Well, here we're calculating a lot of things. And are we breaking or something, or why is it still calculating? Okay. I'm not as interested in seeing the mazes every time anymore. Calculating path for Q. You know, this is something we could probably also cache in the file system. That would make it a bit easier. Python file system cache. Disk cache. I don't want to use a library, I just want to kind of dump something. Maybe we can now parse a JSON as a dictionary or something. For Python, write variable to file. You can use wrapper. Okay. Let's see a little bit later if we can do that. And actually generator cannot use length, even though I tested it with a range, and apparently a range is a bit different. Range can return a length without actually even though it's a generator. Oh, okay. Excuse me. Well, running. Is anyone still working on yesterday's puzzle? I know that not a lot of people finished it, so I think there is a chance that some of you are still working on it. So int object is not iterable. So that means that here you're working on it now and you got it last night. Oh, you're not working on it now and you got it last night. I see, very nice. And yeah, You're almost frying your computer. So why can't we do a length over this? We're getting the shortest path for every key. Oh, wait a second. We cannot just do a key there. We have to say where the key is. So we have keys, key. Like that. And maybe I can actually do what they say here to write my shortest path to a file. So that is the key path. Key paths. That is what I'm going to write. Key paths. I'm gonna write something like that. And then otherwise I can try to import it or something. You generated all the paths and the program did not end. Obviously, but the intermediate result was good enough. So actually you found a path and that worked. Just like that. Okay, so now we did write something, I hope, to key paths. Maybe in the parent directory, yeah. Let's move it. Let's see what it looks like. It is a huge dictionary, as I hoped. And now, can I actually load that file? Can I do like import key paths from key paths? No. Key paths. Or it's called dict. I don't want to do that. Key paths. Is it working? Is it not working? No. Why not? Unresolved reference. Oh, maybe I should do like day19.keypaths. And my Python and interface is so slow right now that I'm not sure if it's not working or not. Import expected. Oh yeah, it works the other way around. That's why. That's true as well. Yeah, okay, so on the other hand, you've learned how to write generator functions in Python. Cool. With yield. And of course a little special trick that we learned also last week, that yield can also take values into a generator. So you can use it to send values into it. And Craspel, you set yours up to have a cap on the path depth. But you set it to a wrong answer. You set it to a wrong answer you submitted previously. And is it because you got a hint that it was too long or something, or too short? Any new solution had to be shorter than that, and if I found a solution, then the cap got lowered again, which let me prune a lot of the search space. That is actually a great idea. Unfortunately, I haven't tried anything, so I basically could give some kind of answer here and see if it's lower or higher than that. That feels a little bit like cheating, using the answer system. But in your case, you did actually come up with a valid path, so I wouldn't consider it cheating. But it is a good way. But you're just doing paths, and you're not deciding on keys or anything. You're just doing paths. Any path that works, basically. Okay, where are we now? What I just did is importing the key paths, and so if that one is available, then we don't need to calculate it like all over. And here I define it. So I will now define it a little bit near the function where it's populated. And that is here. So actually, where am I calculating it? It's in this loop here. Maybe I can just do like try or something, just in case it doesn't work. Accept, and then pass. And then if we have key paths, or if we don't have key paths, then we're going to run this code. And otherwise not. Except E, maybe? Or what is it? Yeah, this should be correct, right? Let's run it. calculating path to each key, and that is very quick. But in the end we don't have key paths. And it does look kind of nice. It does look the way I think it should look. We also have other keys except for M, because I see mostly M. Let me search for a colon. Yeah, we do have other keys, like here is a W. Okay, so we have all the key paths. And why is it not going well? Why is it breaking right away? Getting dependencies, and that's where it stops. So we also have key dependencies that we need to calculate. Aha, yeah, that is true. So let's open this file and write also key dependencies with the key paths and the dependencies. That's going to be written here, and we're going to import it. Import key dependencies, and those are actually, this is the way I wanted to do it. Yeah. And key dependencies is defined here above. Wait. Otherwise it will be empty. And we are calculating it here. Okay, let's run it. Name E is not defined. Why? Maybe like this then. Okay. So I will delete the key paths file and see that it works. Regenerate it. Yeah, it's used, I know. Let's rerun it. So the day is dawning, and you can see now that my green screen is not working very well anymore. It's because probably some light is casting onto the screen and the light conditions are different. That means that my color settings are not working anymore. That is very annoying, and I don't know a good solution for that other than going into my settings and changing them. If anyone who is a streamer knows what to do about this, please let me know. By the way, I'm not using an official green screen. I just bought a piece of fabric that looks green, and I'm selecting a color that's very near to it. But I had to tweak it a lot to get it to work in the morning. So the kind of range of green detection is so narrow that as soon as some shadow is cast on it or some light, it doesn't work well anymore. So we have a key error. So here we are looking up the key, and it looks like the remaining keys is actually, well, where is it going wrong? Is it here or is it here? So here we're getting the dependencies, and that is not a key error. Here we're supposed to have a key error. And the only key we're using here is this part. So I'm not sure how that can be. This time it should run a bit faster. No, because it crashed. I'm not sure why it actually didn't continue. So let's see, we have... okay, the second time we didn't import it from the right location. So I'll do it like this, and in the place where we write it, we also want to write it to day 19. And let's run it again with debug mode on. And the file is called keypath, so I'm just checking how it looks. This looks fine. And here we're having a key, we have remaining keys, and those are actually dictionary values rather than actually the key names, and I wanted to use the key names, not the values. So we run it again, It's calculating again the shortest path. Not, oh, okay, so the dependencies are now calculated very quickly. And the other paths are going to be we're going to have to calculate them on the fly. And then now we're getting into the part where we're using our new priority queue, I think. So, remaining keys. What is going on here? Oh, I think I changed it in the wrong way. I was looking here at the getting dependencies part, and there I had values before. I think that is fine. The issue is it here? No. Ah. Estimate remaining cost. That should take all of the keys. Yes, that is correct. Keys.keys. But that's only for the first step. Before we are actually iterating and doing a depth first search, I'm just making sure that our start path that we're trying out first, which is starting in the middle of the maze with no keys in your pocket and every key still left, that is what I'm going to start with. And to do that, I need to generate a move object and estimate the remaining cost for the player with having no keys in the pocket. And that should contain all the names of the keys. And then to get the shortest path from there, I need to know for each key where it is located, and then calculate the distance from the position to the key. And then when I know the distance, or when I get the shortest path, I actually need to take the length of the maximum one. And what I'm doing now is actually taking the length of the number of paths that we found and then... Oh, wait a second. Oh, that would work. I want for each of them to take the length, but I should do it like this though. I should say, give me the length of the shortest path to that key, return that length for every key, and then out of those take the maximum. Yeah, that looks better, but I'm not sure still why we got an error. Maybe it's because in the second time I'm estimating remaining costs after initializing the first state, I'm doing it wrong also. For example, estimate remaining costs, that is remaining cost here. It is passed as the state of where we are. Remaining cost is not defined yet, so it couldn't be there. That part could not be the problem yet. So let's see if we can actually run this in line. So now we get a syntax error. Now we get the shortest path, that works. And then do we actually get the longest shortest path? We should get a number out of this. So we're calculating the paths to every key from our current position, and that is going to take quite some time. Although I would think that we had already calculated that at this point. Well, how long can you code without breaks? Yeah, I don't know. I don't know, man. Actually, I've woken up at 4 o'clock today, so that is actually 6 hours straight. And that is crazy. But I feel like I'm kind of nearby or something, and that just kind of pushes me to keep going. But I definitely should stop. Okay, let's just run it. So now we have calculated a lot of paths, and I do see, yeah, well, I did eat a banana, but it's not enough, of course. Yeah, let's look at presentation assistant and move this out of the way. Yeah, I also have to do a bunch of other things today, by the way. But, well, yeah. Well, thanks guys for caring about my well-being. I'm feeling pretty good actually, although I do feel like I probably should eat something. We can make it into food porn, although I am not sure if me eating food is going to be considered food porn. But of course I'm open to try any crazy ideas. So at least I want to run it a bunch of times, until we crash it, of course. And here we're going to add none, because apparently I am putting the new costs into as none. That is this part here. So the remaining cost here was estimated to be none, but actually we have a remaining cost like this, and we should add 0 to that for the costs so far, and then the remaining cost is going to be defined here. Reformatting code slowly. Oh man, it's calculating that again. Still didn't remember that. Maybe we should cache all of the paths that we can calculate in some kind of file. Every single one of them. So remaining cost 406 steps at least. And we are going to try the next one. That is 406 left, and we have no keys found yet. And which key are we targeting? We're targeting key V. You know what, I'm going to try to run this on this example X, which was a very difficult one. Input.txt will be replaced with example X. And let's see if that runs a little bit reasonably. Key error V, yeah, okay, right. We are caching all of our distances, but it doesn't work as long as we're working with anything else than the real input file. So if the input file is something, where are we importing it again? So if input file is not the 19/input.txt, then we're going to raise an exception like this, not importing caches. Then we can run it. Okay, it found a lot of keys, and we don't see the maze. I would like to see the maze. Nice music in the background, by the way. Kind of funny. So our loop is here, and then our maze is going to be printed here at the end. So then we can see actually what it's doing. And remaining cost is shown as 0, so that's definitely wrong. I'm not sure why that is the case. Oh yeah, here I have it. So it is the new remaining cost that we should still add. And if this is working, then I'm going to run it in the background and going to have some breakfast. So for the next key, the remaining cost would be... Remaining cost is the cost not after obtaining the key, but the cost of what you estimated so far at that point before getting the key, I think. When we start, we have a remaining cost and we have no keys. Okay, so when we do actually find one key, we should calculate remaining cost with that key already in our pocket. So the new remaining cost equals get estimate or something. What was it? Estimate remaining cost using the position that we are. That is new position, I think, or key position. And then the new found keys. And then the priority consists of remaining cost with this one. And yeah, I think we should not use this new priority here. No. We can calculate that for every key separately. So that is going to be this. That is the new estimate. And that is going to be used here. Maybe just priority then. New priority. So we have total cost, which is the cost so far. We have the new cost. This total cost, we're not using that, right? No, we're not using that. Total cost should be... Well, I should basically remove it from my statements here, total cost. I'm not even sure if that has a well-defined meaning. So we have the priority, which is total steps. And we have cost, which is the steps so far, and we have the remaining cost. Okay, let's run it. So the remaining cost is high. Sometimes it is changing around, and here we have the priority. And we do jump from low to very high priorities. I'm not sure if that indicates a problem with our priority queue. It can be. That can actually be. And we might want to print the top few strategies to make sure of that. So if we run one iteration, takes a bit of time, then we'll find that these are the top, not 3 but 10 strategies, and we have some priorities. All of them are 26, so for now it's all the same. We run it again, and now we get 6 as the best option, and we're also taking 6. And now our options are changing. I want to turn off word wrapping for now if I can. Not sure how to do that. View mode. No. Not here either. I don't think there are options for it, probably. Simplified variables view. No. Maybe word wrap. Nope. Or wrap. Soft wrap. Use soft wraps in console. Valerie has solved it also. Nice. Good job. Oh, actually I have soft wraps on. I had it off, but it's still showing. Okay, weird. So our best priority is now 6. And of course, after trying all of the 6 priority options, then we're going to get something that is a lot higher. But maybe that makes sense. Maybe I shouldn't worry too much about that. So let's not print the strategies anymore. Just keep running it until we're done, hopefully. And in my done section where we are detecting the goal, we do not have a break anymore. And I do want that, and that is going to be our break point. So let's rerun it. So that takes a long time, I suppose, even though, yeah, it takes a long time because there's a lot of branching, because all of the options look kind of similar. Yeah, our cost estimation function is of course very bad. It's like, it's estimating the furthest door or the furthest key and then adding 1 for every other key. That is definitely not a good estimate. And now I also get a warning that my computer is running out of disk space, and that means that is because I have already recorded 15 gigabytes of data for today. And so to solve that, I'm going to remove my files from my cloud drive, and I'm also going to pause the stream so I can have breakfast and fix this issue. I want to thank everyone for hanging out. I enjoyed coding with an audience. Do talk to me on the chat if you want to ask something, if you have Python questions, or you want to discuss your solution, or if you're stuck on a problem and you want to get some tips. Please do that. I am completely fine with that. And I see also that my camera has frozen right now, so I'm going to just end the stream, and I'll see you maybe later today or maybe tomorrow morning. I'm not sure if I will be able to continue today. So have a good day and see you again. Bye bye.